Good morning, everybody, and welcome to the annual conference of the Master's Programme on Climate Change, Agriculture and Food Security here at the University of Galway. My name is Professor Charles Spillane. I'm the Director of the Ryan Institute here at the University, and I'm also the Director of the Master's Programme on Climate Change, Agriculture and Food Security. Myself and my colleagues on the MScCCAFS Programme Committee, we established the programme back in 2014 in partnership with the Consultative Group on International Agricultural Research to provide interdisciplinary training and education to produce graduates skilled in the arena of climate change, agriculture and food security. Since then, we've had over 200 graduates from our programme who've gone on to become major change agents in this arena with a wide range of partners around the globe. Our programme is as important today as it was back in 2014 due to the deepening climate crisis that is affecting all sectors of our society. As we approach the COP28 climate summit towards the end of this year, it's quite clear at this point that the 1.5 degrees target will be overshot by the end of the century, and that we have passed the point of no return in relation to that. On the climate adaptation front, climate change is going to increase the frequency and intensity of climate shocks, and those shocks will be felt by those that are the most vulnerable on the planet. And so there's a real strong need to strengthen the resilience, particularly of those that are the poorest in our society. And then if we look at progress towards the Sustainable Development Goals, the 17 SDGs and their associated targets, what we find is that while there's progress on some fronts, there's also a lack of progress in many other fronts. And this is has been aggravated by the COVID-19 pandemic, but also armed conflicts that are ongoing around the world. So they're slowing the rate of progress towards the 2030 targets. Those 2030 targets were framed around the ambition of leaving nobody behind and reaching the furthest behind first. And that's a key part of our program is to skill our students in understanding questions around social inclusion and social equality in terms of climate change transitions. Indeed, those transitions, those climate change transition pathways will need to navigate many trade-offs and co-benefits between many other development outcomes, in addition to just dealing with the climate change problem. And these include food security, global health, the biodiversity crisis, access to clean water, and sustainable consumption, and indeed social inequality itself, amongst others. So these are all key topics of sustainability research and innovation that are underway and actively under research by the 100 or so research groups that we have within the Ryan Institute here at the University of Galway. So it's against this backdrop that we really welcome you to this year's conference, where our students will present the research that they have been doing on a wide array of topics relating to the program with our partner institutions, and where their research, we would hope and have ambition that would accelerate climate action for sustainable development. We're very proud of our talented graduates that we consider to be agents of change for climate action. In addition, we have two other presentations that we've invited. One is from the Irish Forum for International Agricultural Development from Patrice Lucid, and the other is on the Cliff Grads program of the Global Alliance on Agricultural Research Gases, which we host here at the Ryan Institute by Lungile, who's going to present that. Okay, so at that, I'm going to hand you over to my colleague, Dr. Peter McKeown, who works with me on the master's program. Peter is the coordinator of the MScCCAFS program, and who's going to introduce the first session and speakers. So over to you, Peter, and I'm looking forward to a range of exciting talks. Thank you.
Thanks, Charlie. For our first session, we're really happy to have Sarah Mannion, Sean Yates, and Zenan B talking about different aspects of climate mitigation and adaptation relating to livestock systems. And this is really critical because, as we know, livestock are integral to many people's livelihoods, cultures, but they also have very high carbon footprints. I'm going to hand over to Sarah to talk about the work that she has been doing on pathways for Irish farmers involved specifically in the suckler beef sector. Then we'll hand over to Sean and then to Zenan. Hope you enjoy.
Hi everyone, I hope you're well. My name is Sarah Mannion, and the research title for my research project was Rural Livelihood Options and Just Transition Pathways for Beef Suckler Farming Systems and Value Chains Impacted by Climate Change. So I've been involved in suckler farming all my life, growing up in the west of Ireland. So this topic and the future of this sector is of great interest to me. And the main aims that I was trying to achieve from this research was just to investigate farmers' willingness, if any, to transition from suckler farming into another farm system. If they do have interest, what farm systems they would consider transitioning into, and also the key enablers and barriers that they face in engaging with these other farm systems. So here when we talk about suckler farming, we talk about calves that are left with their mothers longer than they typically are in other farm systems. So calves will be turned out onto pasture with their mothers when the weather allows, and the calf will be allowed to drink the mother's milk until the calf is being sold. So I guess just a bit of introduction into the suckler sector in Ireland. So every year across the Irish agriculture sector, suckler farming is the least profitable. So in 2022, 47% of suckler farmers received less than €5,000 family farm income. But as well as their low profitability, farmers in this industry face challenges such as the change in diet and then demand for beef, and also destocking debates around the suckler system, but this system is still maintained and continues in rural Ireland. So the main reasons, I guess, for the continuation of this sector in Ireland is the vital functions that it plays in rural Ireland, such as culture and tradition, which are embedded in suckler farming here. Also gives farmers a sense of identity, sense of community, while also having important economic and social roles. Just to give, I guess, an insight into the economic role that beef production plays in Ireland, in 2018 alone, beef exports accounted for €2.5 billion worth of exports out of Ireland. So then just a background into the destocking debate that's happening in this sector in Ireland at the moment. So the Irish agriculture sector is responsible for 38% of the country's greenhouse gas emissions, and 61.3% of these emissions come from enteric fermentation, which unfortunately is linked with the suckler sector. This just highlights the emission intensity of beef production and suckler farming in Ireland. So this has called for environmentalists and government officials to call for a number of livestock, including the suckler herds, to be cut in order to meet sustainability targets and goals. But if destocking is to occur in Ireland, a just transition pathway lens must be applied. This will ensure that farmers' livelihoods are maintained, if not enhanced. So in recent years in the Netherlands, destocking policy was put in place, but they failed to apply a just transition pathway lens to it, and it led to unrest between the farmers and government officials and led to large-scale protests. So in order for this not to happen in Ireland, we do need to consider just transition pathways for suckler farmers. So just the methods that were employed in this study. So in terms of study design and population, a cross-sectional online questionnaire was used as the data collection tool. The target population for this questionnaire was suckler IFA members. So the IFA is the Irish Farmers Association, and it's the largest farmer representative organisation in Ireland. So it has around 72,000 members. So the IFA, I contacted the IFA county reps, which was 29 in total. Some counties are split into two, and just asked would they be willing to share the questionnaire in their WhatsApp group. So a questionnaire, also a consent form and an information sheet was shared in each county WhatsApp group to contact beef suckler members. All of the questionnaires were anonymous and voluntary. So data collection, a pilot questionnaire was sent out to 5 farmers first, just to ensure that the questionnaire was easy to understand, that the questions made sense to farmers. Once these were collected back again and any necessary edits were made, it included open-ended and closed-ended questions just for a more data-rich questionnaire. And the final number that we got of suckler participants was 52. So just in terms of the analysis, the data was cleaned in Excel just to ensure any missing variables were accounted for. SPSS was used, ANOVA was used for variance, Pearson correlation coefficients were used to just examine statistical significance, and this was set at less than 0.05. And then any open-ended questions were grouped by themes just to highlight reoccurring themes. So just for the first results that we obtained from our questionnaire, so biomass production for biomethane was highlighted as the most popular just transition pathways for farmers. So 11 farmers highlighted that they would consider transitioning into biomass production for biomethane in a move away from suckler farming. Also, it was highlighted from this that at the moment, sheep production is the most common farm practice that's integrated with suckler farming in Ireland at the moment. And then in terms of enablers, 37 farmers, which was out of 52, which is a high percentage. So 37 farmers said that an increase in startup funding will be the most important enabler and I guess incentive to engage with these just transition pathways or these alternative livelihood options. So then in terms of the biggest barrier, this was also startup costs. So 51.9% of 27 farmers viewed startup costs as the biggest barrier to the adoption of alternative pathways in a move away from suckler farming. But not alone that, away from finance, rural culture was also the next biggest barrier. So farmers perceived that a move away from suckler farming into other farm practices would result in a loss of culture in rural Ireland. Also, to be somewhat likely to be a barrier, came in with knowledge and training barriers at 17 farmers and 32.7%. So it also just shows that when you're looking at barriers to farmers, it's not just financial, there's social aspects to it as well, also knowledge and training barriers, which could be improved on to improve the engagement with these alternative farm practices. The next result that we obtained was that the majority of suckler farmers viewed this sector as unprofitable. So the majority of farmers at 24 disagreed that the hours they work on their farm reflects their yearly farm income. So farmers perceive that they're not getting paid for the hours of work that they do on their farm. The majority of farmers at 51.9% also participate in off-farm employment just to keep the farm system financially viable. And 8 farmers at 14.8% disclose that only 10% of their income comes from suckler farming, and equal 8 at 14.8% disclose that only 20% derives from this system. So this just again highlights the unprofitability around suckler farming in Ireland at the moment. And lastly, for the results, we obtained that a majority of suckler farmers disagree that stocking rates are an environmental issue. So 55.8% of farmers disagreed that the stocking rates on suckler farms are an environmental issue in terms of emissions, yet the majority of farmers at 32.7% stock 80 plus suckler animals in their farm annually. So this would mean cows or heifers and calves. Interestingly as well, we found that age and income had no significance on the stocking rates that farmers had, suckler farmers in Ireland. Yet, although they don't perceive stocking rates to be an environmental issue, the majority of farmers at 69.2% stated that they would alter their practices to reduce the emissions coming from their system. So in conclusion, this study was important to give a voice to suckler farmers on their perception of just transition pathways and I guess the future of suckler farming in Ireland. It's important that we learn from things that happened in other countries and ensure that no unrest is felt between farmers and government officials and try and minimise the possibility of large-scale protests. Secondly, biomass production for biomethane, but also organic livestock production and dairy beef integration were identified as possible just transition pathways that farmers were interested in engaging with. An increase in startup funding is the biggest enabler or incentive for farmers to engage with these alternative pathways, while startup costs were also the biggest barrier to the adoption of alternative pathways. So it just shows the importance of finance for this sector in a move away from the high emission farming to a more low emission farming. The majority of farmers are also willing to engage with just transition pathways in order to reduce the emissions from their farm system and boost profitability. So just for a few acknowledgements, I'd like to extend my thanks to the supervisors of this research. So Charlie, Peter, David and Noel, your guidance and feedback has been really helpful. To the IFA executives and the IFA county reps, I'm thankful for giving me the opportunity to collaborate with such a prominent association within Irish agriculture. And finally, the participants of this questionnaire, your knowledge on this topic is much appreciated. Thanks for listening.
Good day, everyone. My name is Sean Yates, and as seen on the screen, we'll be taking a comprehensive look at the potential of nature-based feed additives as methane inhibitors in ruminant livestock. Without further ado, let's dive into the presentation and explore the key findings and implications of this systematic review. Methane emission from ruminant livestock is a major contributor to global greenhouse gas emission and climate change, as methane is 28 times more potent than that of carbon dioxide. Moreover, the ruminant industry is responsible for approximately 40 to 60% of the global methane emissions. As a result, sustainable solutions such as dietary and rumen manipulation, vaccination, and the use of dairy digesters, just to name a few, are practices that are crucial to mitigate methane emissions from ruminant livestock systems, to aid in the abatement of climate change, enhance animal performance and productivity, and ensure the long-term sustainability of agriculture and reduce air pollution. What you are seeing on screen now on this slide is a systematic overview illustrating the mechanism of action and the efficacy of varied nature-based feed additives as methane inhibitors of ruminant methanogens. Essentially, methanogens are microorganisms that produce methane during rumen fermentation in ruminant animals, thus contributing to climate change. Tannins, essential oils, seaweeds, plant extracts, probiotics, and direct-fed microbes are examples of nature-based feed additives containing antimethanogenic compounds that have demonstrated potential to reduce methane production, either by direct methanogen inhibition or modulation of rumen fermentation. Additionally, research is needed to optimize the application and concentration, evaluate the viability of large-scale production of these feed additives, and fully comprehend their mechanism of action. Therefore, nature-based feed additives offer promising strategies that's for sustainable livestock production with reduced greenhouse gas emissions. This slide presents the percentage reduction range achieved by varied nature-based feed additives as enteric methane inhibitors in ruminants. As we can see from the table and box plot, seaweeds have the highest reduction range of up to 99%, while probiotics and DFMs have the lowest reduction range of 33.1%. It is worth noting that the actual reduction achieved may vary based on factors such as feed additive concentration, animal species, dietary composition, and environmental conditions. Therefore, I reiterate, further studies is required to optimize the use of these additives as methane inhibitors and assess their potential effects on ruminant productivity and health. The review highlights the effectiveness of tannins and essential oils in reducing methane production in ruminants. Tannins can reduce methane production by 20 to 30%, while essential oils can achieve up to 40% reduction in methane production under certain conditions. However, the inhibitory effects of tannins and essential oils on methanogens are not completely understood. Careful consideration of dosage, extract type, and possible animal adverse effects is required for their use as methane inhibitors. Additionally, the review emphasizes, again, that further research, including in vivo studies, is needed to validate the effectiveness in reducing greenhouse gas emissions. Ultimately, this study provides a comprehensive understanding of the complexities surrounding the implementation of nature-based, making a unique contribution to the advancement of sustainable livestock production. The scatter plot and bar chart on this slide shows a visual representation of the percentage reduction range of seaweed and plant extract as entering methane. The review highlights their role in reducing methane emissions, particularly seaweed species Asparagopsis taxiformis, which have been found to reduce methanogenesis by up to 99% after scented reports. Plant extracts such as erythrum, among others, have demonstrated the capacity to reduce protozoal and methane production. The stop bar illustrated here, the stop bar shown here illustrates the percentage reduction of probiotics and direct-fed microbials. Both have shown promise in reducing methane emissions from ruminant livestock. These additives can improve the gastrointestinal microbial balance, influencing rumen ecology and methanogen population. Overall, more research is warranted to optimize their efficacy and address constraints such as production costs and regulatory approval. As it relates to the sustainability of dairy nature-based food, when scaled out globally, fully realize their potential, certain challenges must be addressed, such as scalability, feasibility, environmental impacts, and prospective economic concerns. In terms of the environmental impact of large-scale seaweed cultivation, for example, is a cause for concern. Further research is required to determine the optimal dosage and standard application method. A comprehensive life cycle assessment are necessary for determining their global environmental impact. Moreover, the review advocates for a sustainability-focused approach to livestock production in which nature-based feed additives play a central role. The adoption of the nature-based feed additives could be in line with climate change mitigation and sustainability initiatives, leading to incentives and regulations that facilitate their incorporation. Multi-stakeholder collaboration is also important in paving the way for effective adoption and impact. As it relates to key findings, the review discovered that nature-based feed additives can reduce the activity of methanogenic organisms, the principal methane-producing bacteria. The study investigated methane reduction capacity of various additives in depth, providing valuable insight into their effectiveness and sustainability. The potential of additives to mitigate methane emission and contribute to sustainable livestock production has been emphasized throughout the review. However, it is worth noting that further research and practical implications are crucial for achieving a greener and more climate-aware livestock industry. Conclusively, this comprehensive analysis can guide further research, policymaking, and implementation, thereby contributing to a more environmentally conscious and sustainable livestock production. I am convinced that this study has the potential to make a worthwhile contribution to the discipline and may pave the way for a greener future. Thank you for your attention, and I hope this review has been informative and insightful.
Hello everyone, I'm Zinan B, and I'm going to introduce one of the emission reduction pathway. My topic is emissions reduction gains and scaling pathway for anaerobic digestion for low emissions livestock manure management in China. Let's start by describing the current status of China's agricultural emissions and the challenges. The finger on the left represents the main sources of agricultural emissions, which consist of 5 components. There are agricultural land, animal intestinal emissions, rice cultivation, livestock manure management, and agricultural waste belt burning. The purple portion represents the emission for livestock manure management, which account for 16% of total agricultural emissions. As early as 2007, the total amount of manure produced by China's livestock industry has reached to 300 million tons. Faced with the large amount of manure, farmers often lack the centralized manure management system. It results in the emission of methane and nitrous oxide. Current methods of dealing with the environment of agricultural waste, such as the straw burning and the manure dumping, not only create environmental impacts, but also waste a large amount of biomass resources. The disconnection between agricultural cultivation and livestock raising is a problem that cannot be ignored in the current agricultural model. The diagram on the left is a conceptualization of integration of livestock and farmland. The bottom right part of the finger shows the ideal state when agriculture is linked to livestock. This model of farming is marked by low environmental impact and high production efficiency. Anaerobic digestion can be used as a tool to link livestock and farmland. Anaerobic digestion is a process in which organic and biodegradable waste are degraded by microorganisms. The use of anaerobic digestion of agriculture-derived biomass to produce biogas is an environmental management technology for livestock waste. This part, I will introduce the methods of this study. The first step was selection the study area. According to the governance regulation, China has graded pig farming area to control the pollution of waste by livestock farming. There are mainly key development zones, potential growth zones, constrained development zones, and moderate development zones. Based on the dense distribution of water sources and environmental sensitivity, as well as the ethno-religion issue, this study selection the provinces of Shandong, Sichuan, and Guangxi, as well as the provinces of Heilongjiang, Liaoning, and Yunnan as the main province to be discussed. The finger on the left are the GIS map based on the data on temperature, population density, emission density, and pig farming density in these 6 provinces. Through analyze the most suitable province of pig farming based on available data. Finally, calculate the production of pig manure based on the number of pig selectors, and then derive amount of energy that can be converted into biogas from pig manure. Firstly, I will talk about the optimal temperature for pig farming and an anaerobic reactor. The heat storm represents the average annual temperature of selection province in China from 1981 to 2010. Although the survival rate of pig is high, the low ambient temperature will cause pigs to lose weight. 14 to 22 degrees Celsius is the optimal temperature. The appropriate temperature for industrial anaerobic digestion is generally about 35 degrees Celsius. The fingers show Heilongjiang and Liaoning are cooler, with average avenue temperature around 10 degrees Celsius. Guangxi province has an average temperature close to 25. Average temperature in Shandong, Sichuan, and Yunnan stay between 15 to 20 degrees Celsius. It can be seen that the temperature in Heilongjiang and Liaoning are somewhat low. Population density can be used as one of the standards for selecting the province in China, because the amount of population in a city can represent the pork consumption capability of the province to some extent. Pork consumption has a certain market where will promote large-scale pig raising industry. Upper finger indicates that Shandong province has significantly higher population density than other 5 provinces. Pig farming density and the population density has roughly the same trend. More pigs are farmed to provide enough feedstock for anaerobic digestion response. The additional carbon footprint of transportation from the other provinces is avoided. I also choose the ratio of nitrous oxide emissions to provincial area as an indicator, because the original data test only includes the data on nitrogen oxide in emissions. The data include agricultural, industrial, and domestic emissions in the province. Nitrous oxide emissions are increased by use of fertilizers and the deposition and the disposal of livestock manure. Therefore, this study also takes these indicators into consideration. I calculate the ratio of province total emissions to the provincial area and use this ratio to represent the province emission density. Plotted data shown above, we can see that Liaoning province has the largest ratio of emissions, followed by Shandong province, which is second only of Liaoning province. Because the biogas produced can be used to replace the energy and the fossil fuel energy sources to some extent. Therefore, despite the high emission density, it still can be considered as potential province. Based on data presented previously, it can be concluded that Shandong province has the greatest potential for promoting AD reactor of using the pig manure. This conclusion is based on the finding that Shandong province has the favorable temperatures and the market with a certain size of consumer and available scale of pig farming. Based on this calculation, I calculate the potential of biogas production from pig manure in Shandong province. The calculations are shown in the finger on the left based on the Chinese National Bureau of Statistics. I calculate that 170 million kilograms of pig manure as raw materials can be equipped to a capable of 10,600 tons coral after anaerobic digestion of methane. In conclusion, the possible use biogas for anaerobic digestion of pig manure has a circular energy loop effective linking livestock, cropland, and farmers' livelihood, reducing greenhouse gas emission from agriculture. Our study provides initial calculation, but feedstock for anaerobic digestion can be varied. For example, the meat, the livestock manure, and some household waste can be used as raw material as well. There is the potential for emissions reduction pathway in China by displacing fossil fuel with biogas from anaerobic digestion of biomass.
谢谢 Sarah 和 Sean 的分享。那么接下来我们就进入到我们的 Q&A 环节。
That's all. Many thanks to Professor Charles Belling, Dr. Peter McPhail, and Professor Simi Zhan for their help with my thesis. And thank you so much for listening.
Thanks, Peter. This session is focused on levering societal change for urban food systems and sustainability transitions. This is an important topic. As the IPCC indicates, agri-food systems are pressurized by the current environmental degradation and climate change, which of course affects food availability. And one manifestation of this is rural people moving to nearby cities, so-called internal migration. Migration has many positive impacts, for example, sending back remittances to rural areas, bringing new ideas to cities, or bringing ideas back home to rural areas when there is circular migration. But with urbanization, there is also an increasing footprint and pressure on resources. So we do need a multi-level perspective in the analysis of societal change for sustainable transitions. And apart from data and knowledge, we need coordination across actors and sectors. And we also need to consider and incorporate resources that are becoming scarcer, such as water and energy, and incorporate and consider resources into urban planning. So these themes are covered in this session. And our first speaker is Nicole Alwian from the USA, who will give a presentation on how human migration can enable sustainable dietary transitions of urban food systems. Nicole will be followed by Caroline Wambui Kamara from Kenya, who will give a presentation on understanding barriers and enablers for clean cooking transition pathways for the city of Nairobi, which is a rapidly growing city. So I'll now hand you over to Nicole for her presentation.
Hello, my name is Nicole Alwan, and I'd like to thank Professor Charles Spahn and Dr. Peter McEwen for the opportunity to speak to you all about my thesis project. The project is titled Human Migration Can Enable Sustainable Dietary Transitions of Urban Food Systems, and it was completed in conjunction with the Eco-Food Systems Research Program in the Ryan Institute at the University of Galway. We need to shift to more sustainable diets in order to reduce negative health and environmental outcomes, and this is particularly true in urban areas. At the same time, rural-urban migration is set to increase to 2050, which will cause more collision between migrant diets and pre-existing urban diets. Based on this background, we asked, what is the impact of human migration on sustainability and health outcomes of urban dietary transitions? And what we ended up with is a perspective paper. And for those who aren't familiar with perspectives, they're very similar to review articles, but with a sort of forward-thinking, speculative edge to them. So they try to nudge research in a certain direction. So our perspective argument is more research on migrant dietary practices can enable evidence-based interventions for sustainable transitions of urban food systems. Our methodology began with a literature review, which identified existing knowledge on migrant diets in relation to health and sustainability, as well as gaps in that knowledge. Second, we created an evidence-based argument, basically by saying, based on the evidence out there, here's a pattern that indicates something really interesting and potentially useful about migrant diets, and here's how future research could explore this more deeply. Number three, we identified what research needs to be completed in order to test that argument or that theory. And number four, we proposed a methodology for future research. And last, we did take some time to propose some potential opportunities for sustainable interventions based on future research outcomes. Current research on post-migration diets focuses a lot on developing to developed country migration, as well as the phenomena of dietary acculturation and the health outcomes that come from dietary acculturation. Dietary acculturation is essentially when migrants tend to pick up the dietary practices of their destinations, sort of reducing or abandoning their original dietary practices. As far as gaps go, we did find significantly less on migration to, between, and within developing countries. So we did identify that as a research need, more research on post-migration diets in developing country destinations. At the same time, we saw very few studies looking at the sustainability outcomes from migration and dietary acculturation. So we also identified this as a need, studying the environmental impacts of these two. So we do identify these research needs, and and the gaps in the research, but we also identify some really interesting and meaningful patterns in post-migration dietary practices. So while it's important to acknowledge that migrant diets are going to differ vastly depending on the origin of the migrant, migration pathways, et cetera, migrants do tend to lean more toward traditional characteristics in their diets. And what this means is, generally speaking, more whole grains, more fiber, more fruits and vegetables, less animal source food like meat, dairy, et cetera, and less processed food. On the other hand, urban areas, while again differing vastly based on where they are and the level of urbanization and globalization happening there, they tend to have a higher prevalence of globalized dietary practices. And this is generally defined as more animal source foods, more processed foods, more fats, more sugars, and less whole grain, fiber, fruits, and whole fruits and vegetables. Now, Eat Lancet shows us that we should be leaning more toward traditional dietary practices for our own health and for sustainability. This is called their planetary health diet. And if we take a look at the diagram here, the dotted line represents that planetary health diet. And so it's kind of the healthy boundary there we have set. And so anything kind of going outside of that is going to relate mostly to the globalized diet. So that increase, that sort of overshoot of the red meat intake and the starchy vegetable intake. And then anything inside the circle is going to be closer to those traditional dietary values. So we have way undertake of our consumption of nuts and whole grains and other items there that fit more in that traditional diet. So if we can kind of shrink down those globalized dietary practices and broaden up those traditional practices, we can meet at that healthy boundary. So when we pair this with the prevalence in the literature of dietary acculturation, where again, migrants tend to adopt dietary practices of the destination, this often means that they abandon or reduce traditional dietary practices in favor of more globalized ones. And this is, of course, going to exacerbate the globalized diet problem. However, it's important to note that not all dietary acculturation is bad. So some migrants might be coming from a situation where it was hard to meet their nutritional needs or those of their families. And in that case, having more diversity in an urban environment and more access to this globalized diet can have good nutritional outcomes for some. Based on this evidence, though, we propose that new research focuses on mapping the urban sweet spot between migrant and pre-existing diets. And we define this sweet spot as an intersection of traditional and globalized diets where the desirable beneficial practices from each are enabled and adopted within each urban context. So if pre-existing urbanites and migrants can be enabled to meet at this intersection, we contend that transitions toward more sustainable urban diets could be accelerated. So we took some time to map out the urban dietary sweet spot research. So this is what we argue, the different research points and data points that could be found in order to kind of lead to some interventions and policies that can help with sustainable dietary transitions in urban areas. So each rung of the ladder sort of informs the rung above it. So this bottom rung is going to the data points there, and then the outcomes of that research are going to inform the middle rung of the ladder. The middle rung and the bottom rung combined are going to inform our sort of action rung, which is the top rung, creating policies and interventions for those transitions. So the opportunities that we identified for interventions for migrant-enabled sustainable dietary transitions start with addressing drivers of dietary acculturation, which are usually very complex and can be very social. So we do contend that an interdisciplinary approach to this is likely best. Facilitating two-way integration is also really important because this encourages destination populations to take up migrant practices, including food practices, as well as vice versa. We argue that this is actually necessary for pre-existing dietary practices in urban areas to be improved through in-migration. Offering traditional inspired foods in collective eating areas in schools is also a great way to get many people in one place at one time, eating healthier and more sustainable diets. Interventions also that leverage social desirability, in other words, make healthy, sustainable behaviors more trendy or otherwise socially favorable, is also likely to increase those good behaviors. And then lastly, delivering adequate dietary education and options is important. Things like language barriers, lack of familiarity with food, and assumptions about health of destination foods can really accelerate dietary acculturation. So if we're going to give And so we need to give this education so people are aware of what the healthy and sustainable choices are. And then, importantly, the food system at hand also needs to be able and prepared to provide the options that are being recommended in that education. So in this tale of three cities, we see Hanoi, Vietnam, Cali, Colombia, and Bahir Dar, Ethiopia, really representing how important it is to have urban region specificity here in this type of research. Each urban food system has really distinct characteristics. And so for urban region specificity, initiatives are likely going to differ based on the levels and forms of urbanization and food systems transitions taking place in those cities. So in Hanoi, we can see we have an informal and expanding food system. Bahir Dar, we have rural and traditional food system. In Cali, we have a modernizing and formalizing food system. This is all based on the food systems typology. And so if we have these very different starting points in the level of urbanization and globalization and food system transition in the cities, we're going to need very different approaches to the research and also, of course, to the policies and the planning. It's also important to note that Bahir Dar, for example, sees very little international in-migration, but in Hanoi, we see a lot of international migrants from Korea and China, and in Cali, many from Venezuela. So again, where migrants are coming from and their migration pathways and experiences are going to inform the types of foods and practices they're bringing to food systems. Again, just reinforcing this idea that we need to have very specific research and localized initiatives to really make sure that the transitions are useful and effective. So by reviewing this research area, what exists, what doesn't yet, and what needs to exist, we found that there is a need for improved modeling of healthy and sustainable intersections between migrant and pre-existing diets in urban areas. If we do this, if we have these localized urban region-specific models on hand, then we can provide an evidence base to better inform decision-making by food system stakeholders for sustainable dietary transitions in urban areas. Thanks again to my project supervisors and to the funders of this research. And thanks for listening.
Hi, everyone. My name is Caroline Kamara, and I will be presenting on understanding barriers and enablers for clean cooking transition pathways for the rapidly growing city of Nairobi. Nairobi is the capital city of Kenya, and it is a place where innovation meets tradition and where the challenges of rapid urbanization are as captivating as landscapes. Despite being thousands of miles away from many of us, Nairobi's journey towards clean cooking holds valuable lessons for all, a journey filled with barriers to overcome and enablers that could shape the future of urban living worldwide. In this rapidly evolving city, Nairobi's population is booming, with a population of 5.3 million, a 4% increase from 2022, reflecting a broader trend across the African continent. Over the next few decades, Africa's urban population is set to increase, with an estimated 60% of the projected 3 billion Africans living in cities by 2063. Urbanization comes with a surge in energy demand, and one of the most fundamental aspects of daily life, cooking, stands at the forefront of this transition. As urbanization accelerates, the way Nairobi and other African cities approach cooking will not only shape their future, but also global efforts to address sustainability and energy access. The biggest factor causing degradation in the African continent is biomass harvesting for energy purposes. Where demand exceeds supply, such unsustainable wood fuel harvesting results in deforestation and associated land use change, leading to habitat loss, degradation of ecosystem services, and increased landscape greenhouse gas emissions. Sustainable Development Goal 7.1 aims to ensure access to affordable, reliable, and modern energy for all by 2030. To achieve this goal, it is crucial that roughly 1 billion Africans transition from traditional inefficient fuels to more efficient and clean energy sources by 2030. This transition is essential for improving living conditions, reducing environmental impact, and achieving energy sustainability. As of March 2023, 98 countries with low or middle incomes out of a total of 132 incorporated clean cooking to their nationally determined contributions. The emphasis in promoting the use of better stoves, reflecting a growth awareness in policy circles of the need to improve public health while transitioning to cleaner cooking. However, the inclusion of clean cooking in indices does not necessarily equate with action on the ground, as both investment and scaling are necessary impact and outcomes of clean cooking transition. Household income levels exert an impact on the usage of wood fuel. An increase in household income is associated with a transition towards the adoption of clean fuels in most cases. Kenya has advocated for the implementation of improved cook stoves and cleaner fuels. This is partly driven by the nation's commitment to meet its objectives to reduce greenhouse gas emissions by 30% in 2030. A number of policy measures are underway, including the Labeling Initiative for Clean Cooking Technology. The domestic market for LPG in Kenya has developed with 55% uptick in urban areas in early 2023, driven by a range of factors, including the introduction of small 6 kg cylinder and establishment of a cylinder exchange pool. As a result, Kenya currently has the highest level of accessibility to clean cooking alternatives within the East African region. The primary objective of our study was to conduct a spatial analysis to map the distribution and adoption of clean cooking technologies in 4 distinct regions within the Nairobi County. We used secondary data to explore any correlations between the choice of cooking fuel and the trend over time among individuals residing in Nairobi County and the factors that contributed to the choice of cooking fuel. We used the World Bank MFT Energy Database 2020 to acquire data on the predominant cooking fuels used within Nairobi County. And to better understand how biomass is used for cooking, we analyzed DHA surveys from 2003, 2008, and 2014, along with a malaria indicator survey conducted in 2020. From the study, we used the World Bank MTF Energy Database to analyze household cooking fuel preferences in 4 significant Nairobi constituencies in 2020, that is Nairobi North, East, West, and Westlands. The data set included data from 475 households. Firewood and charcoal were used the highest percentages in Nairobi East and West. These areas have the most urban poor households, and transition to clean cooking is determined by the availability, knowledge, and the cost, since many rely on daily wages. We conducted a comprehensive analysis of cooking fuel trends in households using the data from the demographic and health surveys for the years 2003, 2008, and 2014. Additionally, we included data from the 2020 malaria indicator survey, although some fuel types were omitted from the analysis due to data limitations. We observed a decline in the use of firewood for cooking, representing 98% reduction. The adoption of electricity increased as well as the use of LPG natural gas. There was a decline in the use of kerosene, with a notable resurgence in 2014. The adoption of gas showed a gradual upward trend as more households embraced it. However, when considering the total number of respondents, this adoption rate remained relatively limited. There was some evidence in the sheets of biomass used in cooking in Nairobi households. The figure in the left shows clusters in Nairobi City in 2003, and the figure on the right shows clusters in Nairobi City in the year 2014. We saw a need for in-depth study to explore biomass utilization and distribution in clusters. What are the factors determining clean cooking transition in Kenya and Nairobi? Number 1, economic. The integration of the LPG gas in Nairobi's urban landscape has experienced growth propelled by innovative strategies like the implementation of pay-as-you-go technology. This system is tailored for households with limited financial resources, allowing them to make LPG purchases that align with their consumption patterns and income. LPG adoption is particularly common among urban households, driven by the emphasis on time efficiency, the reliability of refills, and higher income levels. Number 2, sociocultural factors. The decision to adopt and use specific stoves is influenced by dietary habits and the size of household. In practical terms, improved cook stoves are often preferred for their convenience in preparing quick meals. On the other hand, traditional biomass is commonly used for cooking local dishes that require longer preparation times and accommodate larger pots. Stove designs that align with the user preferences and facilitate the preparation of local dishes are favored, whereas those that do not cater for such needs may have lower rates of adoption. Knowledge and perceptions. Understanding the adverse health effects associated with traditional cooking methods, access to accurate and up-to-date information about clean cooking technologies, their benefits, and access can influence choices. Perceptions of the acceptability of clean cooking practices within social circles, perceptions of the initial cost of clean cooking technologies, perceptions of traditional cooking methods as integral to cultural identity may hinder the acceptance of clean alternatives. For example, safety concerns over distribution and refilling of the LPG cylinders and a lack of standardization by the government can be an issue of concern. Gender dynamics and gender roles. The adoption of soft technologies is closely linked to gender roles within the household. When women lack decision-making authority over resource allocation, priorities might shift away from stove purchases in favor of more urgent needs. On the other hand, men who are less affected by the use of traditional cook stoves might have lesser motivation to invest in upgraded options. In conclusion, economic uncertainty may slow clean cooking transition in Nairobi, thereby making most households to return to traditional biomass use due to economic challenges and cost effectiveness. Therefore, incentivize improved cook stoves for extended biomass use and efficient energy use should be made a priority to the households in Nairobi. There should be leverage LPG levies to enhance accessibility and affordability. There could also be an awareness campaign through the communities and social media for cleaner fuel adoption, and also strategic policy measures, incentives, and awareness campaigns to increase sustainable transition. In conclusion, I would like to thank my University of Galway supervisors, Professor Charles, Dr. Peter and Yared, also Dr. Caroline Ucheng, for their unwavering support and patience. I would also like to thank the IFIAD for the funding and also enabling my studies and growth. Thank you.
Congratulations, CCAFS students, on your research projects. My name is Patrice, and I'm going to introduce you to the Irish Forum for International Agricultural Development. The forum was set up in 2016 as a platform for all of the Irish actors who are engaged in international agricultural development to collaborate. And we have quite a few organizations coming together under IFIAD, including universities and research, NGOs, businesses and farmer organizations, and government agencies. And indeed, Ireland invests around 66 million euros annually in agricultural initiatives across the African continent under its international development programs. So why agriculture? Well, we understand agriculture as being key to transforming the livelihoods of people living in poverty. That's because most of the world's poor reside in rural areas, and they rely on agriculture for their livelihoods. And for that reason, agri-food and rural transformation is seen as an important pathway out of poverty and towards achieving the Sustainable Development Goals. But it's not just agriculture. In the past, agriculture was focused on production and the availability of food, but now it is much broader than that, taking into account the idea of food systems. So we will be looking at environmental sustainability, climate change, adaptation and mitigation, nutrition and diet, gender equality, and issues around social equity and inclusion. So all of the areas that I've seen coming out in your projects today. But working in this complex system, it really requires multi-stakeholder approach. So we have many exciting partnerships underway in Ireland that really exemplify the strong network and collaboration that has been developed. This example here is a partnership between Ireland's Agri-Food Research Agency, CHAGASC, and researchers in Tanzania to develop a sustainable and climate resilient dairy value chain. Some other examples are partnerships around the dairy sector in Eritrea and Ethiopia, development of the potato sector in Kenya. And what all these projects have in common is they're highly collaborative and they bring together Irish universities, researchers and development agencies with local partners. And you'll also see here University of Galway's Legume Project, which is working in 4 countries. IFIAD's role really is to support this leveraging of Irish agri-food expertise towards development goals. And we do this primarily through knowledge sharing and learning. We have different meetings and learning events during the year, including our flagship annual conference, which marks World Food Day. And we also engage in policy processes, both domestic and international. And you can find out more about this in our website, ifiad.ie, or by signing up to our newsletter. And I would encourage you to join IFIAD to connect you to the diverse network that we have in Ireland. This is actually a very exciting time to get involved in agriculture and food systems. There's a lot more space opening up now for young people to engage in international policy and advocacy. And here you can see some of Ireland's youth representatives, including Bertha Cassonde, who is here today and who represented Ireland's youth statement at the World Food Forum. There are also opportunities for young people in research, for example, Walsh scholarships, or in project management and agribusiness with NGOs and agri-food enterprises. I'm going to leave you with a quote from the president of the African Development Bank when he was speaking in Dublin recently. And he said that the future of food is in Africa. So if you're interested in issues of agriculture, climate, and food security, we would love for you to join us in IFIAD.
Dear, this is my pleasure to present the next 2 master students from Climate Change, Agriculture and Food Security, Linda Breslin, who did her work on measurement and mitigation of environmental footprint of music events, and Shamila Shikandi, who made her work on satellite remote sensing of nighttime lighting for measurement and enabling national-scale rural energy access transition in Tanzania. Welcome.
Hi, my name is Shamila Nasizi, and I'm a climate change, agriculture, and food security student at the Ryan Institute, University of Galway. I completed my thesis, which I will present to you today in collaboration with the Lake project here at the Ryan Institute. My research focused on satellite remote sensing of nighttime lighting for measuring and enabling national-scale rural energy access transitions in Tanzania. In this digital age where technology connects us like never before, it is easy to forget that over 770 million people, mainly in Africa and Asia, still lack access to the most modern convenience, electricity. According to the International Energy Agency, the electricity access gap in sub-Saharan Africa still persists, despite the remarkable advancements in getting access to over 60% of the total world population. However, a very deep divide lies beneath these statistics. In urban areas, access to energy is abundant. However, the story takes a different turn as we shift our focus to rural communities. Here, the absence of electricity not only keeps homes in the dark, but also holds back entire communities from reaching their full potential. This disparity is often influenced by factors such as income poverty, infrastructural constraints, energy prices, and several other factors. Amidst these challenges, SDG 7 resonates as a beacon of aspiration. Over the years, state actors and non-state actors have worked to foster universal access to affordable, reliable, modern, and sustainable energy. Now that we understand the pressing need for universal energy access, let's delve into an equally important concept, just transitions. A just transition is a framework that ensures that the shift towards cleaner and more sustainable energy doesn't leave anyone behind. This is important because transitioning to cleaner energy isn't just about flipping a switch. It's about ensuring that this change doesn't excavate existing inequalities. It's about fairness, equity, and inclusivity. In our quest for sustainable energy, we must find a balance between reducing greenhouse gas emissions and providing reliable energy services to underserved populations. Often, it's the most vulnerable communities that feel the brunt of these transitions. Our research focused on energy access in rural Tanzanian communities, which we'll delve deeper into. Looking at the progress that has been made in Tanzania over the years, Tanzania has abundant energy resources, including natural gas, hydropower, biomass, solar, wind, and other renewables. These diverse sources are essential for ensuring energy security and sustainability, and Tanzania has been making significant investments in cleaner energy sources. The country's emphasis on environmental sustainability is a testament to its commitment to a greener future, as outlined in its Sustainable Energy for All Action Plan. To bridge the energy gap in rural areas, Tanzania has rolled out several pioneering programs. These include the Rural Energy Agency, the Tanzania Renewable Energy Expansion Program, and the Renewable Energy Feed-in Tariffs. These initiatives are not just about clean energy, but also about making energy accessible to rural communities. And the government has also fostered private sector participation in the energy sector. In this study, we utilized satellite imagery to assess rural energy access in Tanzania. Our primary data source was a composite of NPP VIRS version 2 images that were sourced from the annual Visible Infrared Imaging Radiometer set, covering the period of 2015 to 2021. The images had a resolution of approximately 500 meters, and these images are freely accessible from the Earth Observation Group. These images were then analyzed in QGIS using the raster zonal statistics, where we were able to calculate the sum and the mean of nighttime light pixels in the images and merge them to the Tanzania administrative layers to get the nighttime light statistics for each region. Our methodology was validated through a village survey that was conducted by OpenMap Development Tanzania in 2018 across 1,923 villages in mainland Tanzania, providing ground truth data for comparing the analysis. We also integrated spatial data from OpenStreetMap, the World Resources Institute, the World Bank, and the Global Human Settlement Layer throughout this study to enrich our analysis. This approach allowed us to comprehensively assess Tanzania's energy access dynamics and electrification progress trends with accuracy and reliability. Firstly, we combined nighttime light intensity with village data to assess energy access. The darker shades in this map signify regions with lower nighttime light radiance, indicating lower electricity access, while the brighter regions indicate regions with higher nighttime light radiance, signifying higher electricity access and urban development. Green circles represent electrified villages, which were about 33.9% of those surveyed, while the red circles denote those that did not have electricity access, which accounted for 66.1%. One of the things that really stood out here was the concentration of all the off-grid villages in the same regions that were also found to have lower nighttime light radiance. This data informs targeted interventions for equitable energy access. Secondly, we observed the trends of nighttime light radiance to understand the electrification progress across the regions from 2015 to 2021. We observed high nighttime lights in areas such as Dar es Salaam, Zanzibar North, Zanzibar South, and Central, which also happen to be urban areas with higher population density, indicating electrification progress. Regions such as Njombe, Rukwa, and Ruvuma stood out to have lower nighttime lights, indicating slow electrification progress over the years. We also noted fluctuations in regions like Iringa, Morogoro, and Tanga. Thirdly, we explored the correlation between population density and nighttime lights across the country. The results indicated a strong positive correlation where population density changes could explain about 62.46% of the variation in nighttime light intensity. This finding shows that population density plays a significant role in determining the level of nighttime lighting in different regions of the country. The correlation also suggests that urbanized and more economically developed regions tend to have greater nighttime lighting as compared to rural areas with lower population density. In our final assessment, we delved into the alternative energy sources within these villages, shedding light on the vital role of mini-grids in promoting energy access. The outstanding finding here is the prominence of solar power as an emerging and substantial energy source. Regions like Arusha, Kilimanjaro, and Lindi all have showed embracing solar energy, signifying a growing adoption of renewable energy solutions within rural communities. However, in some regions like Dodoma and Rukwa, we observed a high prevalence of generators and car batteries. This reliance on backup power solutions suggests the possibility of intermittent access to electricity and emphasizes the need for more sustainable and reliable energy sources. The village survey also evaluated energy sources and lighting practices, and the results showed that firewood was the dominant energy source, closely followed by candles and kerosene lamps. However, fewer respondents mentioned modern energy alternatives like torches, highlighting the continued use of traditional sources as readily available biomass resources. And these findings also emphasize the need for tailored interventions to promote awareness and access to cleaner, sustainable energy solutions within these communities. To conclude, our research has illuminated critical aspects of energy access in Tanzania. Our findings consistently highlight the strong correlation between higher nighttime light intensity and greater electricity access, whereas in dimly lit areas, we see energy access cold spots urging targeted interventions. Tanzania's diverse energy mix, which features renewables like solar and hydropower, highlights the potential of localized solutions. Mini-grids in particular emerge as vital components for achieving energy equity. As we look ahead, it is critical to address local challenges through tailored interventions. Effective solutions should be designed based on subnational needs, involving local governments, communities, and development agencies. Our study demonstrates the transformative role of nighttime light imagery as a tool for evidence-driven policies. It guides the formulation of equitable energy transition strategies. In efforts towards universal energy access, our research contributes valuable insights and emphasizes the need for context-specific approaches. Empowering rural Tanzanian communities through energy access isn't just about brighter nights. It's about brighter futures. Sustainable development, environmental stewardship, and socio-economic progress hinge on collaborative efforts by policymakers, NGOs, local leaders, and communities. Together, we can illuminate the path for a more equitable and sustainable energy for all. Thank you for your attention. I would like to thank my University of Galway supervisors, Professor Charles Spillane, Dr. Peter McKeon, and Yari Tasema. I also extend my gratitude to the Open Map Development Tanzania team, my CCAFS colleagues, friends, and family for their support throughout this project. Thank you very much for your attention.
Hi everyone, my name is Linda and welcome to my presentation on my research project, and the measurement and the mitigation of the environmental footprint of music events. Music events or festivals connect people through the impact of music. They provide social, psychological, and physiological benefits for their attendees. They encourage creativity, inclusivity, and self-expression, among many other benefits. However, they are also typically associated with generating waste, primarily as a result of transportation and food waste. As with all sectors or organizations, the music and arts sector are increasingly under obligation to mitigate their carbon footprint. While there are many studies on large-scale music events, there are relatively limited quantitative studies on small-scale music festivals, which is what this study aimed to address. We also aimed to develop a consistent framework for quantifying carbon emissions associated with the festivals, as there are varying methods that can be applied. Our study is in partnership with the Songs of Travel project, lead partner with Music for Galway, which was developed to raise awareness on climate change through the impact of contemporary classical music. At the core of Songs of Travel is sustainability and the concept of slow travel, in which they encourage all of their artists to travel slow. This means that their artists won't fly and instead will travel to concerts or festivals by train, bus, or by foot. The goal of our project is to devise a green policy for Chilissimo, led by Music for Galway, an international classical music festival based in Galway. Our study was based on existing data derived from survey responses from the 2019 Galway Jazz Festival in the west of Ireland. The surveys collected data on artist and audience travel arrangements to and from the festival, food consumption while at the festival, and accommodation. Other categories were analysed, but for the purpose of this presentation, we will focus primarily on travel. The key data that was required from the surveys was the distance in kilometres travelled. The survey responses were extrapolated. The total audience was just over 3,000 and the sample size was 340. In the case of travel, we calculated for two emission values. The first value is for the direct fuel consumption for the journey to and from the festival. The second value we calculated for includes the total life cycle carbon impact of the car for those that travel to the festival by car, which includes the emissions released during the life of the vehicle from beginning to end of the vehicle's life, where it will need to be disposed of with parts of it ending up in landfill. To calculate carbon emissions, we used a database from EcoInvent 3.9 to source the relevant emission factors. EcoInvent 3.9 is a life cycle inventory database that integrates the IPCC 2021 methodology. Results for carbon emissions were expressed in terms of 100-year global warming potential measured in kilograms of CO2 equivalent. For calculating emissions from attendees that travel to the festival by car, the emissions factor is based on kilometres travelled. Therefore, it is the total car journeys multiplied by the average two-way distance per car journey, which gives the total distance multiplied by the emissions factor, shown in equation 1. The method of calculation applied for train and bus were calculated as the number of passenger kilometres, as the emissions factor is not per kilometre as in the case for car, rather it is passenger kilometre. Therefore, it is the number of people multiplied by their average travelling distance. This value is then multiplied by the emissions factor. The same method applied for calculating artist air travel. The total carbon emissions from the festival, inclusive of the total life cycle impact for travel, was over 67,000 kilograms of CO2 equivalent. However, it is important to note the pie chart in figure 2b only represents the 5 largest contributors of emissions out of a total of 13 categories analysed in this study. When fuel consumption only was calculated, the total emissions of the same 5 categories was 47,382 kilograms of CO2 equivalent. As you can see from the pie chart in figure 2a, audience travel contributed 34% of the emissions. Audience food and drink contributed 46%, while in contrast in figure B, where the total life cycle carbon impact was calculated, audience travel was found to contribute almost half of the total emissions for the festival at 46%. Artist flights contributed 10% of the emissions, and the bus, car, and coach at 6% was from the production travel. So you can see here that the majority of the total festival emissions are from the audience transport to the festival. This figure here represents the modal share for the audience mode of transport to the festival. And as you can see, the majority of the audience travels to the festival by car at 43%. However, it is important to consider that these results are based on representative data based on the sample size. Therefore, while our findings provide indicative values, it does not necessarily accurately reflect the true values for the total audience. In this figure, we see that the total travel emissions from the festival were 41,500 kilograms of CO2 equivalent. This value is inclusive of the total life cycle carbon impact for all transport. The grey bar represents the audience travel, which we can see is the highest at almost 30,000 kilograms of CO2 equivalent. The blue bar represents emissions from artist flights, which was almost 6,500 kilograms of CO2 equivalent, contributing approximately 10% of the total festival emissions. The yellow bar represents emissions from production travel, which was almost 4,500 kilograms of CO2 equivalent. And the green bar is from the organization's travel, which was just under 1,000 kilograms of CO2 equivalent. The second largest category of emissions analysed at the festival was from the audience food, contributing a total of almost 22,000 kilograms of CO2 equivalent. Based on the survey results, half of the audience consumed non-vegetarian meals for the duration of the festival, which contributed to the majority of emissions from food, resulting in over 11,000 kilograms of CO2 equivalent. 23% consumed vegetarian, resulting in over 2,000 kilograms of CO2 equivalent, and 5% ate vegan. To conclude our study, since the majority of the emissions resulting from the festival were from transport to and from the festival, with the majority arising from audience travel, followed by audience food, with the majority of emissions resulting from non-vegetarian meals, our study suggests that there is opportunity for festival organisers to influence both their audience's mode of transport to the festivals and the choice of food consumed. Measures include encouraging more sustainable modes of transport to the festival where possible, such as public transport, promoting carpooling or providing shuttle buses, and promoting more local plant-based food for the festival. It is also important to consider the influence the locality has on an individual's decision to choose to drive to the festival. For example, this study was based on the Jazz Festival located in the west of Ireland, where the infrastructure is poor and the public transport system needs improvement due to unreliability of bus scheduling, etc. As a result, many people in Galway are limited in their transport options, which likely accounted for the majority of the Jazz Festival audience having travelled by car. Therefore, it would be recommended that festival organisers collaborate with the city and county councils on the proposals for improvements in the public transport system. Furthermore, a key finding based on our study is the necessity for a more consistent methodology for quantifying carbon emissions associated with festivals, which would include more comprehensive surveys detailing attendees' classification of car. Finally, I would like to express my gratitude to my supervisory team, Professor Charles Spillane, Dr. Liz Coleman, the lead researcher from Galway on this project, Dr. Peter McKeown, Professor Owen Clifford, and Dr. Jeremiah Spillane. I would also like to thank Kieran Ryan, General Manager for the 2019 Galway Jazz Festival, for providing the data analysed in this study. And I would also further like to extend my gratitude for the wonderful opportunity to be involved in the Songs of Travel project developed by Anna Lardy, CEO for Music for Galway. Thank you so much.
Thanks, Linda, for the great presentation. My name is Noah Nglovu, and I'm a PhD student here at the University of Galway. This session will primarily focus on the measures we can adopt to progress towards climate resilient food systems. This theme is critical as we confront the challenges posed by climate change to food systems and the communities they support. As you may know, climate change impacts food systems at different levels, including changes in soil fertility and crop yields, and its effects on the bioavailability and the nutritional quality of foods. All these impacts disrupt agricultural productivity, strain food supply chains, and threaten the economic livelihoods of many communities. On the other hand, food systems themselves contribute significantly to the climate crisis, as they emit about 1/3 of the total greenhouse gas emissions. In light of all this, it is crucial that we initiate the process of building food systems that are not only climate safe, but also climate resilient. In this session, we have two speakers. The first one is Maria Bell Narayan, who worked with us looking at the impact of climate change on access to fruits and vegetables for healthy diets in Fiji. And our final presentation will be from Aoife Roche, whose research project was on dietary change dynamics and resilience of Vietnamese food systems to biophysical and economic shocks. And at that, I hand over to Maria for her presentation.
Good evening and welcome. I'm Maria Narayan, and today I will be giving a presentation on a research project that I carried out in collaboration with the CJR Fresh Initiative and supported by the Irish Aid Program. The project is titled Climate Change Impacts on Access to Fruits and Vegetables for Healthy Diets in Fiji. Before I begin my discussion on how climate change will impact Fiji's food systems, allow me to share about the vulnerability of the Pacific Island nations. The South Pacific region is home to a diverse group of about 15 countries. The archipelagical nature of these nations exposes them to the spectrum of climate-related hazards, ranging from rising sea levels and intensified tropical cyclones to altered precipitation patterns and ocean acidification. These climatic shifts disrupt traditional agriculture practices and reduce the availability of locally grown fruits and vegetables. Fiji Islands, located in the western tropical Pacific, are highly susceptible to the impacts of climate change due to their geographical location and reliance on agriculture for food production. Of particular concern is the accessibility of fruits and vegetables, which are essential components of sustainable and healthy diets. Climate change has the potential to disrupt fruit and vegetable production, affect local agriculture practices and food systems, alter nutritional content and quality, and further limit availability and accessibility. Therefore, this study aims to address the following research questions in relation to the impacts of climate change on access to fruit and vegetables in Fiji. To better understand how climate change impacts access to fruits and vegetables in Fiji, to assess direct and indirect effects on the availability, nutritional quality, and supply chain, to develop guidelines to ensure reliable access to nutritious food despite climate challenges. By addressing these research questions, this will contribute to the understanding of climate change impacts on food systems and inform policies and interventions to combat these issues. The research methods used were to outline the steps and procedures that were undertaken to investigate the impacts of climate change on access to fruits and vegetables in Fiji. Under literature review, this involves identifying relevant articles and studies related to the thesis topic. Keywords such as climate change, food security, fruit and vegetables production in Fiji was used to narrow down the search. Under data collection, domestic production of fruits and vegetables, data was collected from FAO Stat website. Information regarding the annual production, quantities, and values of different fruits and vegetables was obtained for a 10-year period between the years 2011 and 2021 to capture long-term trends. Export and import information was collected from trademap.com, a comprehensive trade database where reliable information on the quantity and value of exported and imported produce was gathered for the same 10-year period. Meteorological information was obtained from the Fiji Meteorological Office and worldclimate.org. These data included historical climate information such as temperature, rainfall, and extreme weather events that have occurred during the selected 10-year period. Mapping of climate vulnerable areas, the ArcGIS software was employed to map out the climate vulnerable areas in Fiji. Moving forward to the results of the project, the shared socioeconomic pathway scenarios, specifically SSP 2 4.5 and SSP 5 8.5, were chosen to determine projections for temperature and precipitation changes across Fiji's land area between the years 2021 to 2040. These climate mappings were overlaid with the current locations of fruit and vegetable productions in Fiji. Analyzing both climatic maps so that as temperatures were projected to rise under the S2 SSP scenarios, it was evident that several crops may encounter significant challenges in adapting to these elevated temperature changes. Precipitation patterns, as highlighted, are also posed to undergo significant shifts across Fiji. Excessive rainfall poses a complex risk, including waterlogging, erosion, and the outbreak of diseases, all of which can collectively undermine crop health and productivity. Furthermore, the inclusion of trade maps from which fruit and vegetable imports to Fiji originated was used. Some of the countries that currently supply fruits and vegetables to Fiji may be challenged to continue to do so as climate change proceeds. At present, Fiji imports of fruits and vegetables originate from a diverse set of countries, such as Indonesia, China, Australia, and New Zealand. The import data indicates that the most imported fruit and vegetable crop is potatoes, consistently exceeding 20,000 tons per year throughout the entire decade. Onions follow as the second most imported vegetable, with quantities consistently over 10,000 tons per year. Dried legumes and other frozen vegetables are also notable import categories. The import data indicates that imported fruits such as apples, pears, citrus fruit, and nuts, while present, constitute a much smaller proportion of Fiji's imports. These fruits each amount to less than 5,000 tons per year, reflecting a relatively lower demand for fruits compared to vegetables. On the other hand, Fiji's position as the hub of the Pacific is highlighted, emphasizing its role as a significant agri-food trade player in the Pacific region. The most exported crops are root and tuber vegetables, including cassava, taro, and sweet potatoes. Each of these crops consistently accounts for more than 10,000 tons exported annually, indicating the importance in Fiji's agricultural export portfolio. Clearly, there is some evidence that farmers in Fiji are already perceiving the effects of climate change on their agriculture production activities. Household surveys conducted by Fiji Ministry of Agriculture on agriculture households in Fiji over a 10-year period from 2010 to 2020 provide an indication of farmers' perception of different impacts on their activities across provinces and divisions, which could have a climate change driver. Out of a total of more than 70,000 agriculture households surveyed, many reported they were experiencing multiple negative impacts, some of which may have a climate change component. Loss of soil fertility is the most commonly reported impact, observed by 48.9% of the agriculture households surveyed. A decline in crop yield is the second most prevalent impact noted, with 49.1% of households reporting this impact. The spread of new pests and diseases were noted by 33.2% of households. These impacts are likely to have a significant increasing climate component contribution. While the production and import and export of fruits and vegetables provides some indication of availability, it does not address the question of accessibility of fruits and vegetables, particularly for those who are most malnourished in the Fijian population. Fruits and vegetables are key components of a healthy diet. In Fiji, there are significant cohorts of the population that suffer from malnutrition based on the data on the nutrition status of the Fijian population over a 12-year period from the years 2010 to 2022. This was sourced from FAO-STAT. For instance, while Fiji experienced a lower proportion of undernourishment than the per year average for Oceania countries, excluding Australia and New Zealand. Between 5 to 10% of the population suffer from undernourishment. As a child, undernutrition has major implications for future health and disease burdens, and on social capital. The percentage of children under 5 who are stunted is a key indicator of Fiji's stunting rates, which are less than 10%, implying that the prevalence is relatively low compared to other Pacific Island countries in the region. Fruits and vegetables are key sources of iron, which is essential to reduce levels of anemia in the population. Again, Fiji has consistently high levels of anemia amongst women of reproductive age, indicating that on average around 31% of women in Fiji have anemia. Strategies to mitigate the impact of climate change on food systems should thus take into account the specific dietary needs of women, especially those of reproductive age, to ensure their health and well-being. In conclusion, the interplay between climate change and access to fruit and vegetables for sustainable healthy diets in Fiji is a complex issue with far-reaching implications for food security, nutrition, and overall well-being. These findings highlight the urgent need for comprehensive and integrated strategies to address the complex challenges posed by climate change impacts on access to fruits and vegetables in Fiji. Mitigation and adaptation efforts must consider not only agricultural practices, but also trade dynamics, market access, nutritional education, and policy intervention. In the end, I would like to express my sincere gratitude to all those who have supported me throughout my journey of completing my thesis. Their unwavering guidance and assistance and encouragement have been invaluable to me. Firstly, I would like to thank the Irish Aid program for granting me the Irish Aid Small Islands Developing State Scholarship, of which I wouldn't have entered this program without their help financially. Secondly, to Professor Charles Spillane and Dr. Peter McGowan for shaping my research and enhancing my academic journey. My co-supervisor, Mr. Denny Hunter from the CJR Fashion Initiative, for his invaluable co-supervision and support. The Fiji Meteorological Office support staff, especially Mr. Ravil Kumar, Mrs. Varnise Sevuniyawa, and Mr. Anish Kumar for their assistance throughout the data collection process. And lastly, to Mr. Yared Dasima, a PhD student, for sharing his knowledge of the basics of GIS software and mapping. Thank you.
So today I'm going to be talking about the dietary change dynamics and resilience of Vietnamese food systems to biophysical and economic shocks. I'm Aoife Roach, and I did this as part of the Eco Food Systems research project here at the University of Galway. So, why Vietnam? Vietnam is one of the fastest growing economies in the world, contributing significantly to the global food trade and exports high levels of rice, seafood, and coffee, for instance. It is also a major beneficiary of international food trade. And we believe that the increasing food import dependency may affect the resilience of Vietnamese food systems. It goes like this. Dietary change affects demand of goods. If demand cannot be met by national production, consequently, demand must be met from external sources. This import dependency influences resilience. So, to guide the research in the study, I developed an integrative food systems framework to measure resilience, drawing on concepts and frameworks previously developed by Christopher Bene, the Food and Agricultural Organization, amongst others. Its aim here is to visually encompass most, if not all, factors of resilience matrix in order to facilitate research in understanding nuanced relationships between potential influences of resilience building in food systems. It definitively includes climate change as an influencing factor and encompasses system, community, and household level measurements. In the paper that we intend to publish, we make great reference to the difficulty in finding or agreeing on one term for resilience, as there is no scientific consensus, as I understand it, on what it is in food systems. As such, we tried to include critical factors in this framework, such as physical, social, and financial assets, as they will be very important for transforming food systems to increase resilience and sustainability, enhancing food security, and generating positive social and economic impacts. So, after determining resilience for the project, I had to ascertain the shifts in Vietnam's food systems. For instance, how it's changed over the last number of years. By using the databases here, such as the FAO stat database on food balances and those from the Vietnamese General Statistics Office, we ended up with a two-tiered approach in analysing the food system. So first of all, we looked at the production data, import and export patterns over time, and trends to determine reliance on countries for specific food and agricultural products. So we focused on studying factors in both the supply chain, such as imports for commodity staples, as well as the propensity for shocks to occur in these regions. We also looked at the consumption patterns of key foods and expenditure changes over time to frame the behaviour and changes of consumers, specifically with a focus on Hanoi and the urban population in the capital of Vietnam. So here's our first result, really. Vietnam doubled its food imports over the last decade. So despite having a positive trade balance overall, Vietnam as a country had a negative balance in the case of food and agri-food products in 2022. This is seen in the right graph, as the growth in the last decade in the agri-food sphere has been significant. Hanoi, the capital, has seen a progressive increase of over $10 billion in the city's trade deficit since 2013, and has become increasingly dependent on imports in that region to sustain the food supply. So here, when considering the fragility and reliance of Vietnam's food system, we also need to take into consideration the global food system. So here we have that 6 countries in the world provide more than 50% of Vietnam's total agri-food imports. Next up, we can see where these commodities originate. These agri-food commodities. The categories are intended to represent major commodity groups for foods, foodstuffs, and some agricultural production to represent Vietnam's food system requirements, to give an overview of the fragility of the country's import reliance on selected regions worldwide. In 8 of these categories, the bulk of the value of imports came from just 2 countries. For instance, Vietnam is the 5th largest maize importer worldwide and relies on just 1 country for 70% of that stock, and it's only expected to increase in the next decade. Australia and the United States as well combined provide 83.52% of Vietnam's wheat. This is just a brief overview of the dependency that Vietnam has on countries for many of their agri-food and food products. Here we can see the reliance that Vietnam has on the 5 global bread baskets. That is the United States, Argentina, China, India, and Australia. And if hypothetical synchronized bread basket failures would occur, or potential export restrictions from these major producing countries, it would inevitably destabilize the global food system, as well as Vietnam's itself, because we can see the amount of times they provide Vietnam with goods in this infographic, in these red circles. So next we can see the cumulative change in 3 categories as we break it down, and determine that key staple imports for Vietnam may be under threat. So on the left, we can see that Indonesia provides a significant proportion of oils to the country, replacing Malaysia in the #1 spot in recent years. We can also see this for Cambodia in terms of cashews and China in terms of vegetables. Some of the peaks and troughs in these graphs over time are from shocks that influence global food trade participation, in which an alternative country takes up the slack. However, as future changes occur and demand keeps rising, I think it would be interesting to see what may happen in the Vietnamese food system, as imports may have to change. So here we can see a breakdown a little bit further of soy. So rising consumption of soybeans in Vietnam may be accelerated due to the increased demand of animal products in the country. So we can see that Brazil and the United States are the primary exporters of soybeans to Vietnam, followed to a lesser degree by Canada, Cambodia, and Argentina. This level of importation totaled 1.7 million tonnes in 2022, but the country itself only produced 60,000 tonnes in 2021 and has been on a continuous decline since 2010. Consequently, the country now exhibits a 97% import dependency on soybeans. Soybeans are also under threat globally in that they are predicted to show the greatest losses due to climatic factors in the major producing regions and coincidentally major exporting regions to Vietnam. Climate anomalies as well, such as the El Nino Southern Oscillation, are predicted to affect yields by 7%. So in the event that climate change and climate anomalies affects producing countries, then trade may be impacted, and which could amount to an inevitable deficit, given over 90% of imports of Vietnamese soybean come from Australia and Brazil, for instance. Next of all, we can kind of see a breakdown in consumption here. And I see that dietary trends in Vietnam mimic global food trends. And as the country becomes more urbanized and expenditure patterns change, its palates change. And the dietary changes are seen in this table. So in terms of food, eating habits have changed in the last few years, with an amalgamation of traditional eating habits and transnational westernized influences. So Vietnamese dietary staple is rice, and it's led to a widespread conceptualization of national food security as rice self-sufficiently. However, we can see in this table that rice's importance in the national food diet is decreasing. Vegetable consumption expenditure has dropped, and meat and drinking expenditure for both alcoholic and non-alcoholic beverages has increased. So there's definitive change here in the food system. We can also see that there's links between income and expenditure and the urban-rural divide. So yearly consumption expenditure is changing in line with rising incomes in Vietnam. In addition, households in rural Vietnam have lower expenditure levels and higher food budget shares than their urban counterparts, although urban people do spend more in total on food, in food expenditure. So 30% of an urban consumer's food basket spending is on animal source goods. So we saw in the previous slide that meat consumption has increased it now accounts for 21.3% of total expenditure outlay for consumers. But those such as tofu, eggs, seafood, and legumes combined equals less than 10%. So there is a big difference here. And when we look at the capital, Hanoi itself has the highest spatial cost of living in Vietnam, so it costs people much more just to live. And the region in which Hanoi is in, which is the Red River Delta, we found it has the highest food expenditure. But the dietary diversity and diet quality levels are significantly lower here than another significant city, Ho Chi Minh City. All these different factors affect resilience. So with that, we determined that an extensive reliance on agri-food imports from outside Vietnam may increase vulnerabilities to shocks such as the COVID-19 crisis, climate change, and ongoing conflicts. And this affects food system resilience. Indeed, changing consumption patterns in both urban and rural populations in Vietnam suggests reduced resilience. And I think that future research avenues should prioritize investigating the potential impact of food trade changes on urban and peri-urban areas in Vietnam and their impact on resilience. So I would like to just quickly thank Professor Charles Spillane, Anne Mullen, and Peter McKeown for being exceptional supervisors here. I would also like to thank the team from the Eco-Food Systems Project, and those at Alliance Biodiversity, CIAT, and Ricardo Vietnam for making this happen. Thank you all very much.
Thank you. This session is on climate change, diet, and nutrition. When we consider future food security and climate change, we need to consider not just the quantity of food supply, but also the quality of diets too. So that would mean things like food safety, nutrition and health, and consumer acceptance. Nutrition security is critical for keeping populations healthy, so we are looking for win-wins in our food system, not just for planetary health, but also human health too. Our first speaker today in this session is Jenna Lee from Ireland, and Jenna's project looked at whether plant-based diets have some benefits in protecting and preventing some of the most prevalent and chronic forms of diet-related disease, like type 2 diabetes and obesity. Our second speaker then is Mitroy Thom from Guyana, and Mitroy is looking at a sensory evaluation approach to test consumer acceptance of biofortified common bean in Belize. So over to you, Jenna.
Hi everyone, my name is Jenna Lee. This summer, I had the opportunity to delve into an exciting research project, a systematic review exploring the relationship between plant-based diets and metabolic syndrome. The title of my review is Role of Plant-Based Diets in the Prevention of Metabolic Syndrome, Cardiometabolic Risk Factors, Overweight, Obesity, Type 2 Diabetes, and Gestational Diabetes, a systematic review across life stages. So why conduct this review? Non-communicable diseases, including cardiovascular disease, type 2 diabetes, and cancers, are the leading cause of death globally. Metabolic syndrome is connected to this because having it markedly increases the risk of developing any of these diseases. This review explores the potential of plant-based diets in preventing metabolic syndrome. Metabolic syndrome may be defined as a cluster of conditions. These conditions are obesity, particularly around the abdomen, hypertension or high blood pressure, hyperglycemia or insulin resistance, dyslipidemia involving low levels of HDL cholesterol, the good cholesterol, and hypertriglyceridemia. Diagnosis requires having at least 3 of these conditions. Certain ethnicities, like Black, Asian, and Hispanic populations, face a higher risk of metabolic syndrome. And so the intervention in this review is a plant-based diet, such as vegetarian and vegan diets, and seeing what the potential health and environmental benefits are. This review adhered to the preferred reporting items for systematic review and meta-analysis, PRISMA 2020 checklist. So the research question proposed was, what is the impact of plant-based diets on the prevention of metabolic syndrome, including its components of obesity, insulin resistance, hypertension, and dyslipidemia, and on metabolic health across different stages of the life course? This was framed using the PICO framework. This framework highlights population, intervention, comparison, and outcome. The inclusion and exclusion criteria for articles were defined. Databases Embase, ScienceDirect, and Scopus were selected, and 4 search strings were put together. The meticulous selection process led to the inclusion of a total of 57 studies. A risk of bias assessment was also conducted on the included studies, which I'll delve into shortly. The PRISMA flow diagram, depicted in the next slide, visually shows the selection process. Finally, findings were synthesized and a bibliography was compiled. Here you see the PRISMA flow diagram. The visual representation illustrates the review process, showing how studies were identified, screened, selected, and their final count. This diagram enhances transparency by outlining each step of the study selection process, including reasons for exclusion. These reasons were not a primary research article, the full text was unavailable, it does not sufficiently address the research question, or else the full text was not available in the English language. On this slide, the variety of plant-based diet definitions found in the studies is shown. On the left, the snippet of my results table highlights the wide diversity of these definitions found in the studies. In the middle, a diagram illustrates the range of plant-based diet types and examples of foods such as legumes, fruits, vegetables, and plant-based meat and dairy alternatives. Interestingly, 14 out of the 57 included studies use plant-based diet indices, the most common definition for plant-based diet found in the literature. There are 3 types of these plant-based diet indices: overall, healthy, and unhealthy. The plant-based diet indices are basically a gauge of how well a diet follows plant-based eating. Healthy plant-based foods such as legumes, fruits, and vegetables receive positive scores due to their positive health outcomes. Animal products like red meat and processed meats get negative scores due to potential negative health effects. Moving on to the risk of bias assessment, the potential biases of the 57 studies were evaluated. These biases were selection bias, performance bias, detection bias, attrition bias, reporting bias, and funding source bias. This step of the review was really interesting to do as it ensured the credibility of the findings. On the right, you'll see a color-coded scoring scheme. Red signifies high risk of bias, yellow represents moderate risk of bias, and green indicates low risk of bias. Each study received an overall risk of bias judgment. The image on the left illustrates variation in bias among the studies. Interestingly, 8 out of the 57 studies had a high risk of funding source bias. This means, for example, a study might promote consuming eggs as part of a plant-based diet, but its funding source comes from the egg industry. This raises concern about the reliability of such findings. So conducting a risk of bias assessment is a critical step of doing a systematic review. Next, this slide looks at the study characteristics, designs, and observations. Here, excerpts of my supplementary tables are presented, providing a glimpse into the various features found in the studies. For instance, the studies were conducted across a variety of different regions, with 8 in Iran, 24 in the USA, and others spanning countries like China, Spain, and South Korea. Sample sizes ranged from as little as 23 participants to over 100,000. Age was another factor with a wide span, encompassing individuals ranging from as young as 6 months old to over 75 years of age. So, in conclusion, this systematic review revealed the following key insights. Plant-based diets go beyond animal-based food exclusion. These diets offer potential for better metabolic health. Emphasis should be placed on the importance of the quality of a plant-based diet, and that it should be nutritionally adequate to obtain any health benefits. Plant-based diets also play a role in addressing the climate crisis. The definition or definitions of plant-based diets need to be standardized. Continued research is needed on the topic of plant-based diets and metabolic health. And of course, transparency in research is vital. In summary, healthy plant-based diets hold the potential for improved metabolic health. And just before I wrap up, I'd like to take a moment to express my gratitude and say thank you very much to my supervisors, Dr. Anne Mullen, Professor Charles Spillane, and Dr. Peter McKeown. And also thank you very much to my friends, my partner, and my family. And I'm deeply grateful for the privilege of being able to pursue further education. And thank you for listening.
Hello, everyone. I am Troy Tom, and it is an absolute honor for me to present my final project entitled Development of a Sensory Evaluation Methodology to Determine Consumer Acceptance of Biofortified Common Beans in Bellies. This project is a collaboration between the University of Galway, Ireland, and the Caribbean Agricultural Research and Development Institute, which is the organization that I am attached to. I will introduce this research by giving you an overview of the impacts of micronutrient deficiency. The prevalence and impact of micronutrient deficiency remain high globally. Undernutrition is exacerbated by expensive food prices, which restrict access to nutrient-rich food products. The continuous absence of micronutrients from an individual's diet can trigger life-threatening illnesses, mainly among young people below the age of puberty and in adult females. Deficiencies of micronutrients such as zinc and iron affect over a quarter of the world's current population. Across the globe, the consumption of trace elements such as iodine, zinc, iron, and vitamin A is exceedingly inadequate and pervasive. Within the Caribbean region, zinc deficiency is prevalent among children below the age of 6 and females between 12 to 49 years. Biological process of supplementing the nutritional value of agricultural crops is called biofortification. This process is commonly accomplished through one of 3 techniques grouped as agronomic practices, conventional breeding, and transgenic approaches. Agronomic biofortification, which is promoted as being inexpensive and uncomplicated, involves manually administering nutrients in the form of micronutrient-enhanced fertilizers to the soil or directly to agricultural crops through foliar applications while they are being cultivated to enhance their nutritional and overall health and performance. Transgenic biofortification involves the transferring of genes artificially from one organism to another to generate an offspring with desirable characteristics. The most widely known example of agricultural crop generated using this technique is vitamin A enriched golden rice, which has been approved as safe for consumption in 4 countries, including Australia, New Zealand, Canada, and the United States of America. And it has also been approved for cultivation in the Philippines and Bangladesh. Nonetheless, the most widely deployed approach for biofortification is through conventional breeding, which involves the natural crossing of 2 organisms to obtain an offspring with desirable characteristics. This method has been successful in generating multiple new cultivars of plants, which are currently being trialed and scaled across many countries. Some of these crops include vitamin A enriched orange maize, iron enriched pear millet, vitamin A enriched orange fleshed sweet potato, iron enriched beans, and enriched vitamin A yellow cassava. The process of biologically fortifying food products is proposed as a viable and inexpensive strategy that can help alleviate micronutrient deficiencies of underprivileged populations. Complementary interventions, including the supplementation of food products with micronutrients and the diversification of diets, have also proven to be effective in the alleviation of malnutrition. However, the implementation and sustainability of these techniques is challenging in some contexts. The success of biofortification initiatives depends entirely on the acceptance and adoption of the biofortified crop by consumers and farmers, which can be achieved through a sensory evaluation. This brings us to the ultimate objective of this research, which is to evaluate the sensory acceptance of 10 biofortified common beans in the Toledo district of Belize. Common bean is regarded as a major staple crop of Belize, which occupies 10% of the nation's agricultural land. Even though the Central American country is self-sustainable in the production of common beans, an imbalance of essential nutrient intake along with food instability are prevalent throughout the nation. Research on sensory factors that contribute to customer acceptance and adoption of an unconventional product or crop defines a sensory acceptability experiment. For the purpose of offering imperative knowledge to food engineers, scientists, and marketing specialists surrounding the sensory characteristics specific to food products, this method attempts to differentiate the sensory aspects of unconventional food items. 50 consumers were targeted to carry out this evaluation, and the sensory factors that will be assessed are the taste, texture, and the appearance. The data obtained from this research will be analyzed using SPSS statistics. And just to note that the practical aspect of this research is scheduled to be conducted during the latter part of September 2023. The data obtained from this evaluation will be presented using tables and appropriate graphs. This table will be assessing consumers' preference for consumption of different biofortified bean varieties, while this table will be assessing the sensory characteristics that influence consumers' choice of biofortified common bean variety. Conclusions. While some progress on combating micronutrient deficiency malnutrition in Belize has been made, there remain challenges. Reducing anemia in women of childbearing age. Biofortified legume crops provide an additional strategy for reducing micronutrient deficiency malnutrition in bellies. For biofortified crops to have impact, they need to be adopted and consumed at scale. The preferences of consumers for biofortified beans could act as a barrier or enabler of adoption and scaling of consumption of biofortified beans in bellies. The sensory evaluation study, in collaboration with CARDI, will identify which biofortified bean varieties are most preferred by a panel of consumers in bellies, which will inform national and CARDI efforts to identify which bean varieties to scale up. Heartfelt gratitude goes out to my project supervisors, Professor Charles Spillane, Dr. Peter McEwen, Dr. Galina Bykova, and Ms. Omaira Rostand for their continuous support and guidance throughout this process. Heartfelt gratitude is also extended to IFIAD for funding my studies and CARDI, who will be funding and facilitating the practical aspect of this research. Thanks for listening.
Greetings, everyone. My name is Lungile. I am the Cliff Grads Coordinator, and today I'll be telling you about the Cliff Grads program. Capacity building is very essential to addressing climate change in developing countries, especially countries with the least capacity to addressing climate change vulnerabilities. The UNFCCC, as well as the Paris Agreement on Article 11, address how this agreement can address capacity building in developing countries. The Rhine Institute, in partnership with the Global Research Alliance, as well as the Mitigate Plus, ensure that the Cliff Grads program aims to build the capacity of early career agricultural students in developing countries to conduct their research on climate change mitigation in agriculture. The Cliff Grads program was first initiated in 2011, but has the scholarship started in 2017 and is a joint initiative between the Global Research Alliance on Agricultural Greenhouse Gases, as well as Mitigate Plus, which is the research for low emission food systems. The fellowship now awards 14,000 USD per candidate. Initially, they were actually awarding 12,000 USD per candidate. And the scholarship aims to build capability of early career scientists from developing countries with a mitigation focus on all agricultural subsectors, farm emissions, food losses, and waste emissions. The program aims to provide 50% of fellowship to women, and the funding comes from the New Zealand government, which is the Ministry for Primary Industries, as well as the CGIAR initiative, which is Mitigate Plus. The scholarship supports PhD students from developing countries to conduct research on topics related to the measurement, modeling, as well as mitigation of agricultural greenhouse gas emissions. There is funding for short research stays of up to 6 months in host institutes in another country, which is not the country of the students, and fosters a network of young professionals. And until date, there has been 5 rounds of this scholarship and helps to improve data on mitigation and emissions to reduce the impact of agriculture on climate change. The Cliff Grads awardees are exposed to expertise and scientific training at their host institutes that they would not have otherwise received during their PhD in their home country. The topics that they conduct research on are related to the measurement, modeling, as well as mitigation of the greenhouse gas emissions or carbon storage in agricultural systems that are relevant to their developing countries and food security.
The research is conducted in association with the Mitigate Plus as well as the GRA scientists and partner organizations to host students, and the student research could match depending on the student and the host's institutions, research interest, and suitability for the program. Since 2017, the scholarship has held 176 students from 32 developing countries, which have received this Cliff Grads Award. The Cliff Grads Round 5 awardees count up to 45 students, and they come from various different developing countries. The Cliff Grads holds webinar series every year to for students to discuss and meet with guests and communicate, as well as students get a platform to present their PhD research as well as the research question and share them amongst their Cliff Grad peers. The publication of Cliff Grads, they generate publication which contribute to the research, publication, and output. The publication presentations or posters resulting from this fellowship must always acknowledge the Mitigate Plus as well as GRA and the host institution and other donors that they get in collaboration with during their research. The Cliff Grads has a buddy system where the previous alumni are matched with the new alumni, where they obtain support, cultural, academic, professional support. And the buddy can also share the favorite hangouts, the things that they got up to while they were in their research day and the research host institute. The fellowship is more than just an academic and research experience. The fellowship aims to establish new academic and professional connections. The students experience a new culture, maybe even learn a new language, and they challenge themselves through immersion in a community that is different to their own. And we now hear from what the Cliff Grads alumni say about the fellowship. This is Flavia from Argentina, who conducted her research in India, in Madrid, Spain, where she had a successful research stay, where she had access to skills and skilled technician team with expertise in techniques that are related to soil carbon studies in a laboratory analysis and field sampling. And she outlines how her research stay went about. And next, we have Chaleni, who is from Brazil, who was hosted in INTA in Argentina, where she had the opportunity to expand her network and getting in direct contact with the prestigious researchers and students of the host institute. This is the Cliff Grads team, which is, most of the team is located in New Zealand and the Ministry for Primary Industries, as well as the University of Galway. You can keep in touch and get more information on these platforms, the GRA website. You can also email Cliff Grads on the email shown on the screen, as well as contact us through the Twitter handles that are outlined below. Thank you.
Hello, everyone, and thank you to all the speakers and presenters so far. The next session, session 6, is focused on climate-smart agriculture, legumes, and climate adaptation. Each of our speakers in this session undertook their work as part of the EU-funded Legumes for Development research project, promoting the scaling of legume-based agroecological intensification of smallholder systems for greater sustainability within the water, food, energy nexus across sub-Saharan Africa. Legumes produce high-quality edible protein, and when intercropped with other major crops like maize and cassava, they can have positive impacts on soil health and fertility. This can reduce inputs and costs and contributes to the greater overall resilience of smallholder systems. And if legume crops can be produced successfully at scale across sub-Saharan Africa, they have the potential to transform nutritional, income, and sustainability outcomes across this sector. Our speakers today each addressed a specific aspect of this transformation. Our first speaker is Patience Simwanda with her presentation on climate modelling and mapping to identify cowpea varieties for future climate scenarios and agroecologies in Zambia. Our second speaker is Victoria Balaka, who will be presenting her findings on the opportunities, barriers, and innovations for accelerating legume seed multiplication rates. Our third and final speaker in this session, Tatenda Taguta, will be presenting her work mapping soybean supply to the poultry sector in East and Southern Africa to understand soy poultry-related impacts on livelihood, nutrition, and health. And with that, I will hand over to Patience.
Thank you very much, Harry, and welcome to my research presentation. My name is Patience Simwanda, and I carried out my research under the Lake for Dev project, Rand Institute, University of Galway. My topic is climate modeling and climate analog mapping to identify cowpea varieties for future climate scenarios and agroecologies in Zambia. Climate change poses a significant threat to food security in sub-Saharan Africa. And according to the Intergovernmental Panel on Climate Change, IPCC, Southern Africa is identified as a climate hotspot within Africa. The impact of climate change on crop productivity is exerting pressure on agricultural systems, challenging food and nutrition security, as well as livelihoods. Sub-Saharan Africa heavily relies on rain-fed agriculture, which poses a challenge to cowpea production. There are different classes of predictive modeling tools that can be used to identify the likely impact of climate change on Southern African agriculture. Future climate scenarios can be predicted to assess how crops will respond to climate change. We carried out our study in Zambia, and this is a map depicting the agroecological zones of Zambia and the study area sites. As you can see, that our study areas were in Region 1, which is a low receiving rainfall region, and Region 3, which is a high rainfall receiving region. The methods that we use to carry out our study is the Decision Support System for Agrotechnology Transfer DSAT 4.8, and the image is depicting the climate change analysis which are done in DSAT. As you can see, we need first to have the genetic coefficients which helps in calibrating the varieties into the model. We also need the weather data to create the weather stations for the specific study areas. And then we also need the crop management data for the crop of interest so that we can create the A and C files. And then we also need the soil properties for each study area to create the soil files for the specific study areas. And all this data is used to conduct the experiment, the simulation of experiments in DSAT. And then the outcome of the simulations is the crop phenology and the crop productivity of the particular crop of interest. Then we use the future climate scenarios, that is SSP2 and SSP5 for 2060, that is mid-century. And then we also use the climate analog mapping. The projected results indicate that mean annual temperatures are likely to increase in future. As you can see on our graph, both future climate scenarios show an increase, with SSP5 indicating a higher increase than SSP2. The projected increase in temperature is ranging from 0.34 to 4.12 across all the 4 sites. Then for the projected annual rainfall, which is also projected to decrease in all the sites in Zambia, the magnitude of the difference varies across the different sites, while the difference between the baseline and the future scenarios is higher under SSP 5. As you can see on our graph, the mean annual rainfall under SSP 2 will decrease with a percent difference of -7.57 to -10.58%. Similarly, we've seen that under SSP 5, the rainfall will decrease with a percent difference reduction of -2.13% to -10.58%. We evaluated the mean annual total rainfall and found that the baseline is higher in all the 4 sites, indicating that the future climate conditions will receive lower rainfall. We further went on to find out the relationship between the change in temperature and the change in rainfall. As you can see, we have 2 graphs depicting SSP 2 and SSP 5. And in both scenarios, we found that they all had a negative correlation. For SSP 2, we found a correlation of -0.2, indicating a weak linear relationship between the 2 variables. And then for SSP 5, we found a correlation of -0.7, and this was indicating a moderately strong negative correlation. We summed up the 2 graphs, saying that both SSP scenarios suggest that temperature changes is not correlated with the percent change in precipitation in all the sites. Climate analog mapping suggests that the growing areas of cowpeas in Zambia will reduce. As you can see by our maps for SSP 2 and also SSP 5, the suitable growing areas for cowpea in Zambia will likely reduce by mid-century, particularly under the extreme climate scenario, which is SSP 5. And then the climate analog mapping suggests that there's greater change in cowpea suitability growing areas in the southern region of the country, which is the southern part of Zambia. To conclude, we investigated the likely impact of climate change on cowpea production in Zambia. The model simulations using DSAT were not conclusive. Climate analog mapping indicates shrinkage of areas suitable for cowpea production, especially for the worst case scenario, that is SSP 5.8.5. And then the future climate scenarios and climate analog mapping suggest that cowpea production in Zambia will be affected by climate change. Therefore, there is need for preparedness to adapt to cowpea production systems for future climates. Thank you very much. I would like to thank my University of Galway supervisors, Professor Spilan, Dr. Makion, Dr. Galina, Nondlovu, Yared Tesema. I would also like to extend my thanks to my co-supervisors from IITA, Dr. Sika and Dr. Chikoye. Lastly, but not the least, I would want to thank the Irish Aid for according me this chance to study at the University of Galway. Thank you.
My name is Victoria Balaka. I'll take you through my research project report presentation on the topic opportunities, barriers, and innovations for accelerating seed multiplication rates for more effective scaling of quality seed of legumes. My research project was done in collaboration with the Legumes for Development Project at Ryan Institute, University of Galway, and with support from Irish Aid. I'll now take you through the understanding of the importance of legume seed multiplication rates. So the availability and accessibility of quality legume seed is the foundation of improved crop productivity to meet global nutritional needs for environmental sustainability and also achievement of the Sustainable Development Goals. legume seed availability and accessibility remains a challenge for most developing countries. When a variety is first bred or released, only small quantities of seed are available. Hence, there is need to multiply to get more quantities of seed along the seed supply chain. Therefore, the seed multiplication rate of a crop determines the number of seeds that can be obtained from a single sown seed. However, legume seeds have a lower seed multiplication rate and lower green yields per unit area, which makes them an expensive enterprise choice for seed producers. Limited published research on how to increase the seed multiplication rate of legumes is available because most studies focus on other traits such as green yield, nutrition, pest and diseases resistance. Therefore, the research review was conducted to identify factors that govern the seed multiplication rates in legume species and identify options for increasing the seed multiplication rates of different legume species. The figure is showing the process of seed multiplication from nuclear seed to certified seed. So the hierarchy of legume seed multiplication starts with the nuclear seed, which is the initial genetic material, and it progresses to breeder seed, and from breeder seed, we produce basic seed. From basic seed, certified seed and quality declared seed are produced, but they are produced under guided protocol and supervision to maintain quality. So the last phase of certified seed and the quality declared seed determines the available seed for farmers' use. On methodology, a review of research and technical literature was conducted on seed multiplication practices, challenges, and opportunities. This will be complemented by a survey on seed multiplication practices, challenges, and opportunities across 233 legumes experts, which were already identified. The collected data will be analyzed using the statistical package for social sciences, SPSS version 1.001406 and RR version 4.3.1. Therefore, the barriers to increasing legume seed multiplication rates were identified, and they include the inherent biology of the legumes, that's the genetic makeup, which makes them to have a fewer seeds per plant, and also weather variabilities, such as changes in temperature, carbon dioxide, and water availability, and also poor agronomic practices for seed production in terms of soil management, pests and diseases management, both in storage and in the field, and also pre and post-harvest handling of the crops. So when these factors coincide with each other, or when one of them occurs, it can lead to losses of seed and sometimes even total losses of seed. So we also had to do a comparison of seed multiplication rates of legumes and cereals to have a general understanding on why investors can choose a particular enterprise, especially choosing cereals over legumes. So in this case, we'll compare on maize and groundnuts. For instance, the multiplication rate for maize is 1 to 100, meaning if you plant one seed of maize, you get 100 seeds. And the seed rate of maize per hectare is 20 to 25 kgs. Whereas the yields you get per hectare is 5,660 kgs. Comparing to legumes, the seed multiplication rate is 1 to 8, which means when you plant one seed, you get 8 seeds. And the seeding rate per hectare, you plant around 25 to 40 kgs. However, the actual yields are 1,607 kgs, somewhere there. So you see, as investors choose to multiply cereals over legumes, it's because of the profitability of the enterprise along the seed supply chain. So in the end, most investors or breeders, private institutions will choose cereals over legumes production. We also had to identify the opportunities and innovations for increasing the seed multiplication rates for legumes. So improving the seed multiplication rates for legumes can best be achieved by technological innovations in both breeding and multiplication to increase the number of yields per plant, and also improving agronomic practices that support the production of high quality seeds, high germination rates from all phases, which include the use of plant growth regulators to manipulate the sink-source relationships, or to help plants withstand the biotic and abiotic stresses for the benefit of seed. In conclusion, legumes are critical to climate-resilient pathways towards sustainable agriculture and food production systems. However, there are multiple barriers to scaling legumes for smallholder production and consumption in poor households. Legume seed multiplication rates act as a barrier to the availability of high-quality seed for smallholder farming systems. Therefore, both technical and agronomic interventions and innovations can be deployed to improve the seed multiplication rate of different legume species, which can increase the availability of high-quality legume seed for smallholders. Lastly, I would like to thank my University of Galway supervisors, Professor Charles, Dr. Peter, and Mr. Noel, for the support they rendered throughout my research, and also for the financial assistance for my research from Legumes for Development Project and also Irish Aid. Thank you.
Hello everyone, my name is Tatiana. I'll be presenting my research findings on the topic mapping soybean supply to the poultry sector in the SADC region, that is the Southern African Development Community. To understand soy poultry related impacts on livelihoods, nutrition and health. This is a Lab4Dev funded research with the ultimate goal of scaling legumes for nutrition and food security. In the SADC region, soybean stands out as a pivotal crop. It's not just a vital source of edible protein for the populace, but it also finds extensive use in various industrial applications. South Africa emerges as a front runner in the domain, contributing to 35% of the entire SADC region soybean production. Over the years, we have witnessed a dynamic surge in the poultry sector. This growth is evident in escalating production levels and the expanding land acreage specifically earmarked for soybean cultivation, as indicated by the two graphs. To give you a clearer perspective on yields, they span from a modest 500 kg per hectare to a robust 1,800 kg per hectare annually. And when we talk about production systems, the spectrum is vast, ranging from small-scale individual smallholder farmers right up to expansive commercial farming entities. Shifting our focus to poultry, when we refer to this term, we are mainly referring to domesticated birds, prominently chickens and layer birds. These are primarily raised for their meat and eggs. In the context of SADC region, poultry prominently stands as the most substantial source of animal protein. Delving deeper into what fuels this poultry sector, maize and soybean emerge as the leaders. They constitute the foundational components of poultry feed and, by extension, play an instrumental role in ensuring the industry's sustainability and upward trajectory. However, it's essential to recognize that with the burgeoning rise in the poultry production, there is an undeniable strain exerted on these two resources. As we delve deeper, our investigation turns to the intricate dynamics between soybean and poultry. The pressing questions here revolve around the sustainability, efficiency, and the broader environmental implications of incorporating soy into poultry diets within the region. But what are our primary objectives in this investigation? Simply put, our goal is threefold. Firstly, the aim was to map the soybean supply chain, tracing its journey from cultivation to consumption. Secondly, we evaluated its overarching impact on poultry production. And finally, but most importantly, the mission was to identify and spotlight avenues that pivot towards more sustainable and ecologically considerate practices. The approach used to this investigation included an exhaustive literature review. As for our data resources, we heavily leaned on reputed global databases such as FAO-Stat, various UN databases, our World in Data, and the World Bank databases. For the results, turning our attention to the trade dynamics of soybean in the region, one theme becomes abundantly clear. The driving force is feedstock demand. The agricultural and industrial sectors have an insatiable appetite for quality feedstocks, and this very demand sits at the core of the beginning trade in soybean and its derivative products. These include cake of soy and soybean meal. Steering our discussion towards the interplay of accessibility, marketing, and competitive analysis within the soybean poultry sector, several facets emerge, starting with accessibility. Certain logistical and infrastructural barriers have been pinpointed that potentially impede the seamless access to soybean products. These barriers shed light on areas in need of infrastructural fortification. Transitioning to marketing, our investigation encompassed a thorough analysis of the prevailing marketing strategies. The objective, to gauge their efficacy in amplifying the reach and appeal of soybean products in the market. By understanding both accessibility challenges and marketing dynamics, we can better chart a roadmap for the sector's future growth. Navigating the intricate crossroads of nutrition, consumer inclinations, and overarching global trends, we witnessed some compelling patterns impacting soybean utilization. First and foremost, poultry that's primarily soy-fed exhibits a markedly faster growth rate and yields a higher profitability. This not only resonates with the preferences of producers, but also aligns seamlessly with the prevailing market demands. Additionally, a significant trend to note is the shift in consumer preferences. There is a growing affinity towards meat protein, further solidifying the intricate bond between soy and poultry. In essence, as global trends evolve, so does the dynamic interplay between soybeans and the poultry industry, as indicated by the two tables comparing daily protein supply from animal and plant-based foods between 2015 and 2020 in the region. An essential facet of our study centered on the environmental repercussions and the continuous search for sustainable alternatives in soybean poultry production. Here are some pertinent points to consider. Firstly, water usage. Soybean farming, by its very nature, can be quite water intensive. This presents pressing sustainability concerns, especially in the region where water is scarce. Land use is another area of interest. Burgeoning demand for soybean is often at the expense of forests, resulting in deforestation and the subsequent loss of biodiversity. Then there's the issue of carbon footprint. Both soybean cultivation and the rearing of soy-fed poultry leave a significant mark in terms of greenhouse gas emissions. We must also highlight import reliance. The African poultry sector, to a large extent, is tethered to imported soybean. This dependence in turn introduces economic vulnerabilities and supply chain fragilities. Lastly, our focus isn't solely on identifying challenges, but also on solutions. Hence, a slew of research and trials are currently in motion, aiming to unearth sustainable alternatives to soybean in poultry feed. The goal? A significant reduction in environmental impact. To begin with the symbiotic relationship between soybean and poultry sectors, the SADC region is undeniable. They not only influence each other's supply chains, but also have profound effects on broader landscapes encompassing environmental sustainability, economic steadiness, and socio-cultural evolution. This intricate tapestry of mutual dependence isn't just about challenges. It also heralds opportunities. Specifically, it paves the way for heightened regional collaboration, encompassing both research and trade agreements. Such synergies could very well be the cornerstone of fostering sustainable growth and fortifying reliance in both sectors. Ultimately, a deeper, more comprehension of the soy-poultry nexus becomes indispensable. It's this very understanding that will empower the region to craft and implement strategies that strike harmonious balance, one that champions economic prosperity while staying committed to environmental stewardships and societal well-being. To wrap up, I would like to thank my supervisors and lab for them team, Professor Charles Spillan, Dr. Peter, Dr. Ain, and Mr. Noah Ndlovu. I'd like also to thank Irish Aid for sponsoring my journey at the University of Galway. Thank you.
Hello, everyone, and thanks to IFIAD for sharing the last session, and to Patience, Victoria, and Tatenda for their presentations. In this section, we're going to explore a few potential nature-based solutions to the climate crisis. These solutions are going to need to be integrated into existing land management and landscapes. They might either be embedded into existing food production systems, or they might be coordinated alongside those systems as alternative land uses. First up, we have Caitlin with her presentation, Rewilding the Planet. What are the trade-offs and co-benefits with climate change mitigation and adaptation? And then we have Than presenting his thesis, Microbial Bioinoculants for Regenerative Agriculture and Amelioration of Soil Degradation in the Lower Mekong region. So thanks, everybody, and over to you, Caitlin and Than.
Hello, so the title of my research paper was Rewilding the Planet, What are the Trade-offs and Co-benefits with Climate Change Mitigation and Adaptation? Defining rewilding. The chosen definition of rewilding for this paper has been formulated by myself, influenced by numerous other definitions throughout the rewilding literature. Rewilding refers to the practice of restoration of ecological functions and interactions in order to recreate ecosystems that rely on little or no human interference. Rewilding is considered to be a radical conservation method that, in addition to the biodiversity benefits it provides throughout habitat creation, also claims to have benefits for the climate change mitigation and adaptation. This research aims to explore the basis of these claims and contribute to the wider contextualization of rewilding. The evolution of rewilding. The term rewilding was first coined by scientist Dave Foreman in 1991, around the time species introductions were gaining traction in the public sphere with the Yellowstone grey wolf introductions. In 1998, conservation scientists Michael Soule and Reid Noss devised the addition of the 3 Cs, which make up the basis of rewilding science today. The concept of cores refers to a strong and protected central habitat, such as a national park. Our corridors connect these cores so that mobile species may travel freely or spread between them. Foreman further states that this corridor pillar will become increasingly vital for species in the changing climate as they seek out optimal conditions and escape extreme climate effects. Carnivores pertains to the existence of carnivores in an ecosystem that enforce trophic cascades influencing the rest of the food chain. The carnivore pillar has been extended to include all keystone species that support the functioning of the ecosystem. Carver et al. Was tasked by the International Union for Conservation of Nature's Commission on Ecosystem Management to define 10 principles of rewilding, which draw together input from professionals in the field. However, this has not been widely accepted. Types of rewilding. There are 3 types of rewilding that were chosen for this study amongst a multitude of others. Passive rewilding is a hands-off habitat restoration approach where natural succession is left to take over with no human management or interference. It's a common occurrence in abandoned agricultural land where human management ceases due to lack of financial viability. Pleistocene rewilding restores habitats to species thresholds determined by historical species density records from the Pleistocene era. The only well-documented example of this is Pleistocene Park in Siberia, where scientist Sergei Zimov and his son Nikita have reintroduced a number of herbivores to the area, including bison, elk, and Yakutian horses. This form of rewilding often requires the introduction of taxon substitutes, which are genetically similar to species that have been extinct, as well as translocational reintroduction of species that may not have been present for a long time. Pleistocene Park aims to recreate the mammoth steppe, and there has been attempts to recreate the woolly mammoth for reintroduction here in order to provide mega herbivore disturbance, although this remains controversial. Trophic rewilding concerns the reintroduction of species in order to restore ecological function of a trophic cascade, which impacts the population density of other species in an ecosystem. The most well-cited example of this is Yellowstone National Park reintroduction of the grey wolf, which greatly impacted herbivore populations due to predation and impacted grazing behaviors, which in turn increased forest regeneration. So rewilding versus afforestation. Many nature-based solutions result in fast-growing non-native monoculture plantations. Rewilding specifies the creation of natural forests due to the damaging impacts of plantation forests that they can have on biodiversity and trophic cascades due to limited habitat provisions and the human management techniques. Natural forests are able to sequester twice the carbon of monoculture plantation forests due to their increased resilience to environmental stresses such as drought and fire, and therefore reduce mortality rate. Mixed forests have varying root depths and therefore can better retain water and nutrients in their systems. Rewilding and climate change mitigation. The increase in species densities has been shown in studies to increase the quantity of carbon stored by the environment due to seed dispersal, excretion, and the disturbance of vegetation stimulating growth. Rewilding of waterways can also increase carbon sequestration, such as with the reintroduction of beavers, whose damming has proven to increase aquatic plant biomass and hold sediment within beaver meadow complexes, reducing soil erosion. However, increased species densities does also increase methane emissions, and research should be done to ensure rewilding projects' benefits outweigh their negatives. Rewilding can also reduce wildfire risk, which cause massive carbon dioxide release and contribute to climate change. Increased herbivore density can reduce the fuel load of fires by creating mosaics of different habitats densities, which can reduce plant litter. Wildfire incidence is increasing in the Mediterranean due to global warming and has been exacerbated by agricultural abandonment, which leaves land unmanaged and vegetation dense. This is being used to make a case for rewilding. Finally, experiments in Pleistocene Park have suggested a correlation between increasing herbivore density levels from the Pleistocene era and the reduction in temperature of permafrost. This is important as permafrost thaw could lead to an extraordinary release of greenhouse gases that could massively accelerate climate change. This study shows that snow compaction caused by herbivore grazing decreases the thermal insulation layer in winter, allowing permafrost to achieve lower temperatures. Rewilding and the Sustainable Development Goals. One of the aims of this paper was to contribute to the contextualization of rewilding. And the chosen way to do this was in the context of the most widely accepted measure of sustainability, the Sustainable Development Goals. This conceptual model illustrates this relationship. As we can see, with the practice of rewilding has synergies with SDG 14, life below water, and SDG 15, life on land, due to the biodiversity being at the forefront of the practice. SDG 13, climate action, due to the climate change mitigation effects outlined in the previous slide. Furthermore, SDG 3, good health, as the reintroduction of certain scavenger species such as the vulture is proven to have implications on the reduction of diseases such as rabies and brucellosis. Moreover, SDG 8, decent work and economic growth, as rewilding can stimulate rural economies and provide alternative income streams for owners of marginal lands, such as through game, ecotourism, wildlife safaris, and ecological grants. There are also trade-offs with rewilding in the SDGs, such as SDG 7, clean and affordable energy, as there are potential trade-offs between renewable energy infrastructures and biodiversity in rewilding projects. Finally, there are suggested trade-offs with SDG 2, zero hunger, as land use change has the potential to have implications for food security. This relationship will be explored further in the following slide. Land sharing versus land sparing debate. Land sharing is making accommodations for nature and agriculture, such as hedgerows and wildlife borders. This can have benefits for on-farm biodiversity. However, it can decrease in productivity if cultivated land is reduced. Land sparing is setting aside separate from productive land for nature and increasing productivity on agricultural land. This means that marginal land can be set aside for nature restoration, which may be a more financially productive endeavor for farmers. On the other hand, this can cause leakage effects. Land sparing is touted as the best response to biodiversity loss and climate change mitigation by policy proposals, such as 30 by 30 policy, which is 30% of the earth to be formally protected by 2030, and the half earth proposals that suggests half of the earth should be put aside for nature restoration in order to protect 85% of the plant species. Further research modelling must be done to prevent unwanted implications for food security and leakage effects on climate and biodiversity. Looking to the future of rewilding, the concept of biodiversity-based crediting system, as opposed to solely carbon-based, is being explored, and flaws are emerging in carbon-only focused projects. It is expected that a system of biodiversity accreditation may start to emerge, which could be a great financing opportunity for rewilding projects. This study underlines the importance of defining the boundaries of rewilding as the practice gains traction, and there are an increasing number of projects occurring that claim to be practicing rewilding, and there is currently no accountable body that can confirm or deny this. I would like to thank my University of Galway co-supervisors, Dr. Peter McCowan and Professor Charles Spillane. Thank you to my external supervisor, Dr. Paul West from Project Drawdown. That's all. Thank you for listening.
Hello, my name is Thanongkham from Laos. My research title is Microbial Bioinoculants for Regenerative Agriculture and Amelioration of Soil Degradation in the Lower Mekong region. This review paper aims to examine current status of microbial bioinoculants and agroecological practice in the Lower Mekong regions and their combined potential for regenerative agriculture and soil restoration. I focus on the 3 countries in the lower Mekong regions, including Laos, Thailand, and Vietnam. Agriculture is very important for people in these countries. For example, in Laos, there are 58% of population employed in agriculture sector, while in Thailand 31% and Vietnam 29%. However, unsustainable agricultural practice, for example, and burn farming in many parts of the regions. Also, overuse of agrochemical inputs for agriculture production are impact on soil quality. As you can see from my slide, the graph shows trend of chemical fertilizer use are increased. For instance, in Vietnam, chemical fertilizer used up to 467 kilo per hectare per year. The photo on the slide has some example of soil degradation program in the region. Therefore, microbial bioinoculant and agroecological practice are gain more attention as solution to overcome this problem. I conduct the study to generate a review paper which investigate the current status of microbial bioinoculant and agroecological practice in the lower Mekong regions and their combination potential for regenerative agriculture and soil restoration. My findings indicate that there are 3 types of microbial bioinoculants as biofertilizers available in the region's market, including nitrogen fixation, especially for legumes, phosphorus, potassium, solubilizing and mobilizing, and plant growth promoting rhizobacteria or PGPR for non-legumes. For biocontrol agents, there are several products available in the region's market. Commonly used 5 beneficial microorganisms, including Bavaria, Streptomyces, Metarhizium, Bacillus, Trichoderma. For agroecological practice, there are 4 categories, namely organic farming, conservation agriculture, agroforestry, and integrated pest management. There are a number of trial projects and experiments to investigate potential of combining agroecological practice and microbial bioinoculants. I select 3 studies to demonstrate, for example, use of biocontrol in rice production that can improve efficiency of nitrogen utilization and increase rice yield. Another example is combination conservative agriculture, rice production, and biofertilizers results in reduction of chemical inputs and increase increase farmer incomes. For IPM, bioinoculant with biocontrol agents, Bacillus can control leaf spot in mung bean. Conclusion based on my review, even microbial bioinoculants products are available in the region's market. Also, agroecological practice are performed in the regions. However, there are a wide range of knowledge gaps which present a challenge for evidence-based understanding of what potential or not microbial bioinoculants have for improving agriculture system, including soil health, through combination of agroecological principle. For the future research effort, would useful to assess the efficiency and impact of different microbial bioinoculants when combined with agroecological principle for improving the sustainability agriculture system and livelihood in the regions. My last slide, I would like to express my gratitude to the Irish government to support my study in Ireland. Also my supervisors, Professor Charles Belen, Dr. Peter McKeown, and Dr. Didier Lesser. Thank you for your kind attention.
So that brings us to the end of this year's MScCCAFS Annual Conference. I'd like to thank, on behalf of all of my colleagues and everybody in the university, all of our excellent students for all of their wonderful presentations, where they put lots of hard work into to advance research that is necessary for future climate action. They've been wonderful presentations throughout the day. I'd also like to thank all of my colleagues on the MScCCAFS Programme Committee who introduced each of the 7 sessions and the topics and the speakers today. So as a Programme Committee, we've been very delighted with this year's class. They've been an excellent class, worked very well together as a group, and also very ambitious, and it's quite clear that they wish to make an impact in relation to the arena of climate change, agriculture and food security. I guess, you know, one reflection on all of the presentations today and the topic that is before us is that this year's State of the World Food Security and Food Insecurity issued by the UN agencies has indicated that one in every 10 people on our planet suffers from chronic hunger at present, and that number is not decreasing. That's about over 700 million people, and about 3.1 billion people on the planet do not have access to an adequate diet. That's about 1 in 4 people on the planet. So clearly not everything is perfect with our food systems, and our food systems are increasingly subject to a whole range of different sustainability challenges, climate change being one of them, but also, you know, water crises, biodiversity crises, and so forth. So in that sense, we're redoubling our efforts to try and educate and train our students to work with us and with others and with each other to basically have ambition to try and change the dial in terms of the direction we're headed, particularly in relation to sustainability and food security. So at that, I'd like to wrap up this year's conference and again reiterate our thanks to all of the students. Our thanks also to our colleagues in the College of Science and Engineering here at the University of Galway and the School of Biological and Chemical Sciences within which the Master's Programme is located. We have a wide range of partners each year that we work with closely on the CCAFS programme. So I'd like to express our thanks to those, our colleagues in IFIAD, the Legumes for Development project, which is funded by the European Union, our colleagues across the CGR and from CIMMIT, IITA, ILRI, partners in universities such as SLU, Wageningen, University of Hohenheim, colleagues in CIAT, with whom we've been working for many years, NGOs such as Ricolto, and also UN agencies such as FAO, IFIAD, WFP, and then in a national context, we work closely with the Department of Agriculture here and also Irish Aid. Project Drawdown has been one of our partners for this year, and also CARDI in the Caribbean, and also the Sustainable Energy for All program of the United Nations. So at that, I'd like to say thanks to everybody, and do hope that you really enjoyed today's conference, and do keep in touch. And if you have any questions, you can contact ourselves, myself or Peter McKeown, in relation to the programme, and indeed reach out to the students if you feel that you have common interests with them. So thank you all, and hope you have a pleasant evening. Thank you very much.